so let's proceed. Now, this time naman class, let's talk about the mechanisms of drug absorption inside the body. Oops. So for today class, our objective for this lesson is to understand how drugs are absorbed into the bloodstream, following various routes of administration. Second is to know the difference between different physical, chemical, and physiological factors affecting drug absorption. And lastly is to understand the factors that influence drug absorption. So we will be discussing class the physical chemical factors, and then second would be the physiological factors. Under physical chemical factors, we have drug solubility, dissolution rates, okay, particle size, polymorphism, hydrates, salt formation, pKa, pH, okay, and these are actually some of the things class that we've already discussed in physical pharmacy, but let's just have a review about them, okay. And then the other one class would be the physiological factors affecting drug absorption, such as cell membrane and its properties, transport mechanisms, first pass effect, surface area, perfusion, GI motility, and effects of food in drug absorption, and drugs on GI absorption. Now, quick review class about about absorption. So as you all know, class, absorption takes place whenever we ingest medications or whenever we ingest something. Okay, so normally class, it goes through the GI tract. Okay, medications go through the GI tract. Okay, and then ultimately class into the major site of absorption, which is what we said to be the small intestines. Okay, now the thing is class, normally upon absorption of drug molecules, or sorry, prior to drug absorption from the small intestines, the liver can already begin metabolizing some of these medications, okay, by releasing enzymes known as CYP450. Okay, so the CYP450 class, okay, would usually be produced by the liver, and then the CYP450 enzyme goes into the small intestines and starts metabolizing the drug products, reducing the total amount of drug available for systemic absorption. Okay, and that process class is known as the first pass effect. Now, upon first pass effect, okay, what remains from the drug product now enters the bloodstream and is ready now for distribution. Now, when we say distribution class, that's the transfer of the medicine from to different areas of the bodies, okay, and so on and so forth. Then ultimately class, some of these drug product in the systemic circulation can go back to the liver and be metabolized into its inactive form, while some, of course, goes to their target sites. Say, for example, pwedeng to the heart, to the brain, to the muscles, and so on and so forth. And then ultimately, class, ang main area na pupuntahan ng lahat ng gamot natin would be the kidneys for elimination. So basically, class, that's how drugs are inside the body, or how the drug will circulate the body. That's the entire ADME process. Okay? Now, what are some of the physical-chemical properties of drugs, okay, that play a vital role in drug absorption? Okay, so the physical-chemical properties of the drug class, okay, it's the ability of a chemical compound to elicit pharmacological or therapeutic effects that is related to the influence of various physical-chemical properties of the substance on the biomolecule that it interacts with. So when we say physical properties class, this mainly is responsible for the physical property of drug, okay, sorry, for its action, while the chemical properties, okay, so the drugs reacts extracellularly according to simple chemical reactions like neutralization, oxidation, and or chelation. So here are class the physical properties. Okay, usually it's the particle size, surface area, dissolution, solubility partition coefficient. While for the chemical aspects, okay, so these are the physical properties of medications. While for the chemicals, that would be the extent of ionization, salt formation, polymorphism, hydrates, and complex formation. Now, let's talk about class the physical properties of drugs, starting with particle size. Okay? Oh, sorry, area pala muna tayo, area. So, assuming class, this is the area of drug absorption. So, notice, okay, or sa particle size pala muna, sorry. Okay, so for particle size class, ano ba ang relationship ng particle size sa absorption? Normally, class, the smaller the particle size, mas mataas ang kanyang absorption. Okay? Why, class? Because if smaller ang particle size, ang tendency is mas na ma-maximize yung area of absorption. Unlike that class of drugs with large particle size, okay, the thing is, okay, hindi niya ma-maximize yung area. At the same time, class, kailangan mo pa siyang durugin para lang ma-maximize yung area of absorption. That's the reason why, class, oftentimes, whenever we make medications, like say, for example, capsules, mas mabilis ang absorption ng powders kesa sa mga tablets. Because tablets need to undergo disintegration process pa, while for powders, directly dissolution process na ang kanilang gagamitin prior to absorption. Okay? What about in terms of area? So looking at this class, right? Let's say we have the same amount of drug in the body. In terms of surface area, class, where do you think will the drug be absorbed more? An absorbing surface area of 5 meters squared or in an absorbing area, surface area of 2 meters squared? A or B? This one's A. This one's B. Sa tingin nyo, class, saan mas ma-absorb ang gamot natin?
A po.
Okay, definitely. Thank you very much, Ms. Javines. Thank you, guys. Okay, so definitely class is going to be A. Bakit? Kasi class sa A, na ma-maximize natin yung area. Ibig sabihin, the larger the surface area, class, okay, the larger will be the chances na ma-absorb talaga yung gamot. Okay, as compared to, right, one smaller surface area wherein maliit lang yung kanyang area na pagkakalatan. Okay? That's the reason why, class, oftentimes, in terms of particle size, okay, mas maganda ma-absorb ang mga ang mas maliit na particles compared to drugs with larger particle size. Okay? Excuse me. Now, tingnan nyo ito, class, oh. Based on this graph alone, looking at this, which one has the highest absorption? Okay? With respect to time, which one was absorbed more? Okay, looking at this graph, that would be, okay, blue line. Sige, pwede na yun. I'll take that.
Yung
okay?
fine twig.
Okay, very good. Fine, twin. Now, notice class, anong pinagkaiba, sir, ng fine, itong fine, sa fine with twin? Alam niyo ba, class, kung ano yung twin? Are you familiar with this? Not so much. Okay, okay lang yan. Twin, class, is a surface active agent. It's a surfactant. You know what surfactants are, class, right? Ano yung purpose ng surfactants? Tama nga ba? Okay, para saan ang surfactant? Okay. So guys, don't worry, you can always open your web browsers. You can look for the yes, Miss Avines.
Para po ma-reduce yung surface tension ng liquid.
Okay, pwede, I'll take that. Okay, well, that's for liquids. That's true. It's used to reduce the surface tension of liquids. Pero in this case kasi, class, when you say surface active agents, it improves or increases the surface area. Okay, increases the wettability of certain particles. Pag sinabi natin, class, increases wettability, ibig sabihin, mas napapabilis yung particle na yon na mag-undergo ng dissolution. Alright, before I proceed any further, class, familiar naman ang term na dissolution, right? Familiar ba ang term na to sa inyo? Dissolution. Kinda? Okay? Narinig nyo na ba yung word class na dissolution? I think I mentioned this sa physical pharmacy, but I'm not really that sure. Naririnig. Okay, narinig na. Okay. Alright. I guess mukhang familiar naman ng dissolution, right? Okay, so what is dissolution? Try nga natin. Yes, Mr. Nesio.
Ito po yung state na nadi-dissolve po to the point na nagkakaroon na po ng solution.
Okay, I'll take that. Tama yun. So class dissolution kasi is the process in which a drug molecule turns into its solution form. Hence the term dissolution. Okay? Yan, solution. Right? It's the process of converting a drug into solution form. Now, why would I want my drug to exist in its solution form? Okay? Bakit ko gugustuhin na ang gamot ko ay it's in its solution form? Yun. Sige, Ms. Pihoto.
Ano po, sir? Because we want the drug to be absorbed po since our blood po is in aqueous form.
Okay. Tama yon. Very good. So, tama yan, to be absorbed more. Okay? So, basically, class, if a drug product is in its solution form, it's already in its aqueous form. In short, it's already in its water-soluble form. And it is ready for absorption. Kasi sabi nga natin, ang dugo natin is mainly made up of water. Hence, the only things that can, the only types of substances that can be dissolved in the bloodstream would be drug substances that are in their water form, the aqueous form, water-soluble form. And surfactants, class, again, are agents that can improve dissolution. Whoops, improve dissolution. Okay, can improve dissolution. Mas napapabilis yung kanyang wettability. Kaya nga between fine and if you add, for fine powders, class, mabilis na absorb yun. Pero if you add a surface active agent, mas napaparami pa yung absorption. Okay? As you can see in this graph here. Okay, of course, ang pinakamababa ang absorption would be the coarse ones. Okay? Now, so in general, class, if we think about it, napakaganda pala na kadalasan, we have to reduce the particle size of our drug product, right? Because by reducing its particle size, it is said that we are able to improve a drug's absorption. Okay? Pero if you can still remember, class, sabi nga natin, there are times, class, when we don't want our drug product to be too small, or we don't want our drug product to be absorbed too fast. Okay? Let's say, for example, if we're trying to create modified release dosage forms, we try to hinder a drug's bioavailability by putting it in various plastic polymers, halimbawa, okay, and so on and so forth. Now, in terms of particle size reduction, class, there are instances wherein we don't want to reduce the particle size of a drug, especially for hydrophobic drug. Okay, bakit? Hydrophobic drug, class. When we say hydrophobic, obviously, this is a lipophilic drug. Okay? Now, what will happen if I reduce the particle size of a hydrophobic drug? Ang tendency kasi, class, is pag pinaliit ko yung particle size ng mga hydrophobic drugs, pag nilagay ko siya sa tubig, pag nilagay ko siya sa tubig, magkukumpul-kumpul siya. Okay? At pag nagkumpul-kumpul yan, okay, it's going to reaggregate. It's going to form a large mass. So, halimbawa, originally, ito yan. Particle size, maliliit. Right? Okay? Once exposed to water, ang nangyayari, yung mga particle size na yan na maliliit, nagkukumpul-kumpulan. At anong mangyayari? Kasi nga, hydrophobic sila eh. So, ang mangyayari, class, pag nilagay mo siya sa tubig, like, for example, sa blood, okay, magkukumpul-kumpulan sila, they're going to form a mass, a solid mass, which defeats the purpose, class, of reducing its particle size. Correct? Yon. Now, question, sir, what if kailangan talaga kasi i-reduce ang particle size ng drug kahit siya ay hydrophobic? Okay? Ano ang pwede kong gawin? So, huwag kayong mag-alala because we have an understanding of the physico-chemical properties of these drugs. Okay? What we can do, class, is to prevent these drugs from reaggregating by adding a molecular dispersing agent. Okay? Ano yung examples kasi ng mga molecular dispersing agents natin? We have polyethylene glycol, polyvinyl pyrrolidone, and then we have your dextrose. These agents class prevents the formation of aggregates. So, anong ginagawa nila? Okay? So, what these dispersing agents do, class, is create a thin coating around each particle. Okay? So, nagka-create sila ng coating dyan. Parang kino-coat nila yan. And by coating them, class, putting a coating, iniiwasan natin na magdikit-dikit sila. So, hence, class, na maintain na maliliit yung particle size nila. So, dextrose, polyethylene glycol, okay, polyvinyl pyrrolidone, they create this thin membrane or thin covering sa mga small particle size na to, sa mga small particles na to, which prevents them from aggregating. So, naiiwasan ito. Right? Okay, example of a drug class that does this would be griseofulvin. Griseofulvin class is a antifungal drug. And it's highly hydrophobic. Okay? It's a hydrophobic drug. So, ang ginagawa natin kadalasan sa griseofulvin, we add polyethylene glycol para kahit na maliit ang kanyang particle size, hindi siya magdidikit-dikit pag na-expose sa water. Alright? Okay. So, by definition, class, we say that this solution is the process in which a solid drug enters into solution form. We say that we want it to be in solution form because it improves absorption. Okay? Kasi sabi natin, pag solution water-soluble na at ano lang natutunaw sa dugo, water-soluble forms of the drug. And that is the rate-limiting step in the bioavailability of drugs with low solubility. Now, take note of this class, ha? Sorry, you understand naman, class, what rate-limiting step means, right? Rate-limiting step is the slowest step in a series of kinetic steps. Okay, an example, class, of a series of kinetic steps would be the absorption of a tablet. If this is a tablet, class, okay, tablet. Inside the body, it needs to deaggregate. Okay, turn into smaller particles via disintegration. Okay, so small particles. Okay, then the small particles, class, needs to turn into its liquid form, aqueous form, its solution form. And that is done through the process known as dissolution. Now, once it's dissolved in class, it will ultimately go into the blood. Okay, via a process known as absorption. Correct? Okay, that's the reason why, class, for most tablets, the rate-limiting step would be the disintegration process. Ibig sabihin, ang rate-limiting step, class, is the slowest step in a series of kinetic steps. Now, what about, class, for capsules? Ano sa tingin nyo ang kanyang rate-limiting step? For capsules, say for example. Ano ba, class, ang laman ng capsule? Na-try nyo na ba magbukas ng capsule?
Powder po, sir.
Very good. Capsules are oftentimes containing powders. And these powders, class, are already drugs in small particle size. Kumbaga, naka-aggregates na sila. Naka-deaggregate na pala siya, sorry. So, hence, class, capsules do not undergo the disintegration process. So, class, ano ang rate-limiting step ng mga capsule?
Dissolution.
Very good. The rate-limiting step for a capsule is dissolution. For a tablet, it's disintegration. Now, what if, class, my drug product is already in its solution form? Ano ang kanyang rate-limiting step?
Absorption na po.
Absorption na lang. Exactly, Ms. Pihoto. Because, hindi naman niya kailangan mag-disintegrate. Kasi wala nang i-disintegrate. Wala nang kailangan mag-undergo ng dissolution because it's already in its solution form. Hence, class, for solutions, ang kanilang rate-limiting step is simply the absorption phase na lang. Okay? Now, what if, class, my tablet, my drug, which is a tablet, is hydrophobic? Or sabihin natin, mababa ang solubility niya. Now, class, when we say low solubility, that's low solubility in water, just to be more precise. Okay, pero kasi usually, pag sinabi natin low solubility, isa lang naman ang solvent na pinag-uusapan dyan eh. Kadalasan, it's just water. Okay? So, if a drug class has low solubility in water, sa tingin nyo, kahit tablet, capsules, or powders, ano ang kanyang rate-limiting step? Okay, ano ang kanyang magiging rate-limiting step? Okay, between disintegration, dissolution, absorption, ano sa tingin nyo magiging rate-limiting step niya? Okay. Pili lang kayo sa tatlo. If a drug has poor a low solubility, if a drug product has low solubility, may it be a powder or a capsule, okay, what will be its rate limiting step? All right. Thank you very much, Mr. Reyes. Okay. Class, tatandaan nyo to. Tama kayo dyan. It is dissolution. No matter what class, basta ang gamot mo has low solubility, dissolution will become a problem. Why? Remember, class, anong ba ang dissolution? It's the process in which a drug enters into its solution state. Solution state is a water-soluble state. So what if my drug already has low water solubility? Mabilis yan magdi-disintegrate, pero mahihirapan yan maging solution. Make sense, class? Okay? So that's the reason why, class, whatever the drug product may be, kahit ano pa ang dosage form yan, okay? Well, I doubt it's a solution. Okay? Pero if it's a tablet or a capsule or a powder, if it has low solubility, class, it will always have a problem with dissolution. Okay? Hence, that will be its rate limiting step. Okay? Alright. What about class for drugs with high water solubility? Ano kanya magiging rate limiting step? The drug has very high water solubility. What will be its rate limiting step? Okay, kumbaga, it's a drug product that's very water soluble. Okay, very, very water soluble. Kumbaga, pag hulog mo sa tubig, tubig agad siya. Instantaneous yung kanyang conversion into its solution form. Okay, very good. Very good, everyone. The rate limiting step, class, for drugs with high water solubility, kahit anong product pa yan, absorption na lang ang kanyang rate limiting step. Kasi kung mataas ang water solubility ng gamot, class, mabilis siya magdi-disintegrate, mabilis siya mag-undergo ng dissolution almost instantaneously. Hence, class, absorption lang ang magiging problema niyan. Okay? So, are we clear? Okay. So, yun siya. Alright. Pero generally, class, depende sa dosage form, yung kanyang rate limiting step. Now, for dissolution, class, it's the Noise-Whitney equation that is often used to describe drug absorption. And this is how the Noise-Whitney equation looks like. Now, class, I won't be discussing this. Di naman ito usually pinapa-compute. Okay? Pero sige, kasi nowadays, class, we just use the dissolution apparatus. And we don't, si dissolution apparatus na magko-compute para sa atin ito. Hindi tayo magmamano-mano. Okay? Pero I guess still, nice to know. Right? Medyo relic of the past na ito. But it's understanding the past makes us appreciate the present a bit more. Okay? So yun. This is the formula, class. dm over dt is simply the expression for mass over time. How much of the mass moves with respect to time. How much mass of the drug substance moves with respect to time. And D stands for diffusion coefficient. It's a constant value. A is the surface area of the solid. Sigma is the thickness of the diffusion layer. Ang diffusion layer, class, is this one. It's from this point to this point. Ito. Yan yung diffusion layer. Okay? Di ba, class, try nyo na bang maglagay ng tablet sa isang basong tubig? Huwag niyong galawin. Di ba habang natutunaw yan, may makita kayong parang layer na nagdi-diffuse from the solid tablet. Okay, so yun yung purpose, yun yung diffusion layer. Okay. So CS, the concentration of solvate at saturation. And CS class is the concentration of the diffusion layer. While CB is the concentration of the drug in bulk solution. So kung ito yung tubig class, dito tayo kukuha ng CB natin. Dito yung concentration of the bulk. Dito sa diffusion layer na yan, dyan nakukuha ng CS ko. Alright? Then class, ang surface area, ito yon. From this point to this point. Okay? That will be your surface area. Okay? Yun lang naman siya. Ito nga, sorry, ito. This would be the sigma. Okay? And that's how we compute. Then just apply the values class. Make sure lang the units are cancelable. Okay, then apply the values to the formula that we have here. Okay? Okay. Next physical property class that we have, so we're done with dissolution. Again, it's the ability of a drug to convert itself into its solution form, which is ready for absorption. Now, in terms of solubility class, okay, solubility of a substance at a given temperature is defined as the concentration of the dissolved solutes, which is in equilibrium with the solid solute. Okay, what do we mean by when it is in its equilibrium? Kasi class, normally when we, say for example, ito na lang. Pag naglagay tayo class ng gamot, ng solid drug halimbawa sa isang beaker, ilagay mo siya dito, manonotice natin class, di ba? Nagdi-diffuse pa lang yung gamot niyan by that time. Okay? So, ang diffusion niya class is ganito. Parang gumaganyan pa yan, right? From an area of high concentration to an area of low concentration. So, class, is this system in equilibrium? Equilibrium na ba yan? Okay, is that drug already in equilibrium? Most likely, hindi pa, right? Hindi pa in equilibrium. So, class, normally, with respect to time, so after a certain period of time, ang mangyayari dyan is, para siyang ganito na. So, with respect to time, okay, di ba class, after a while, magdi-distribute yung dissolved solute throughout the solution. Correct? And that time, class, and when you reach that time, we say that the system is already in system. This is a system kasi meron kang may solute, may solvent ka. Okay, so the system is in equilibrium. Correct? Because equally distributed na yung tawag dito, yung solute within the system. Alright? And of course, class, you do know that a lot of factors can affect solubility. So, solubility class can depend on the nature of the solute. In terms of nature of the solute class, is it hydrophilic or lipophilic? Okay? Kasi class, kung yan ay lipophilic, tapos nilagay mo sa tubig, at equilibrium class, it will never reach equilibrium because it will not dissolve in the solvent. Okay, so nature of the solute and solvent. Alright, yung solvent mo ba, is it water or oil? As well as temperature. Alright? Temperature class increases or affects drug's absorption, correct? Okay? Or sorry, drug solubility. So, increase in temperature class, what happens to solubility? Increase or decrease? Very good. Increasing temperature class increases solubility as well. And decreasing the temperature also decreases solubility. pH class, okay, I think, in physical pharmacy class, we were able to discuss the Henderson-Hasselbalch equation, correct? Okay, how salt formation can affect the solubility of a drug. Okay, whether it exists in its ionized or unionized state. Okay, so therefore, that would greatly affect where the drug will become soluble to. Would it be soluble to water? Will it be soluble to the lipid membrane? So pH class affects that, and as well as pressure. So these are stuff class that we've already discussed in physical pharmacy. Now, the solubility of drug may be expressed in terms of its affinity, philicity, or repulsion, or phobicity for either an aqueous or organic solvent. The atoms and molecules of all organic substances are held together by various types of bonds, just hydrogen bond, dipole-dipole, ionic bond, etc. And these bonds class can be broken. All right? What is the strongest bond class that exists? Ano nga ba yung strongest bond natin? Okay. Well, covalent, that's true for drug receptor binding. That's true, covalent ang pinaka-strongest. Pero the strongest bond class that exists would be ionic bond. Okay, very good, ionic bond. Pero for drug molecules and receptors, for drug molecules and its target sites, yes, the strongest bond that can exist is covalent. Don't get me wrong. Inside the body class, the strongest bond that can exist is covalent bond. Yan yung irreversible type of bonding. Pero class, kung yung in general, the strongest bond is ionic bond. Alright? Because it's the bonding between a positive and a negative charge. Okay? Hydrogen bonds are just van der Waals forces, usually created when molecules get close to each other. Okay? Di ba yung dipole-dipole? Yung wherein yung polarity ng compound, nag-shift, positive, negative. Okay, I hope you still remember that. Pero don't worry, we won't be discussing that here now. Just the concepts behind it, the bonding. So what are some methods in which we can use to improve the solubility of drugs? So pwedeng structural modification, alter the structure of molecules. This is very much applicable class for polymorphs. We say polymorphs class. Ano nga bang polymorphs? Sorry, before anything else. What are polymorphs? Okay. Ano nga ba class ang polymorphs? It's okay, you can always open your browser. Okay. It's not actually ability to crystallize, okay, pero pwede na rin nga. Sige, okay na yan. Okay. Class, it's the ability of a substance to exist in more than one crystalline form. Okay? So normally, class, a substance, a polymorph, can exist from one crystalline form to another crystalline form. May it be unstable to stable. Okay? Normally, class, for polymorphs, they can exist in its amorphous and its crystalline form. Okay? Now, class, between the two, pharmaceutically speaking, mas maganda yung mga amorphous forms kaysa sa crystalline form. Bakit? Amorphous form kasi, class, have faster dissolution. Crystallines have lower dissolution because of its stable structure. Okay? Yung mga crystalline natin, class, na gamot, the problem with them is they tend to be so stable to the point na mahirap silang tunawin sa tubig. Unlike that of amorphous forms, mas mabilis siyang matunaw at low temperatures. Okay? Same time, when exposed to water, mabilis din siya matunaw. Okay? What else? What can we do to improve solubility? Use co-solvents. Co-solvents such as ethanol, sorbitol, PPG, or polyethylene glycol. Okay? Common na co-solvent na ginagamit natin are ethanol and sorbitol. Pag ethanol ang ginamit mong co-solvent, you create an elixir. Pero we rarely use elixirs nowadays. Okay, next one, employing surfactants. Again, surface active agents. Remember what we've said a while ago? Between yung kay twin, fine powder plus fine powder with twin. Diba? It improves solubility. And improving solubility, if there's increased solubility, what happens to dissolution? Increase or decrease? Very good. It also causes an increase in dissolution. Normally, class, when we talk about solubility here, we're talking about the solubility of a drug product in solubility in water. Kadalasan yun ang pinag-uusapan natin dito because we want the drug to enter the bloodstream. Okay, and the last thing would be to create complexes, to do complex formation. So, why is solubility important? It's important, class, to pharmacists because it governs the preparation of liquid dosage form and drug must be in their solution form. Okay, prior to absorption. So drugs must be must be in solution form for them to interact with their receptors. Kaya sabi natin, class, for a drug to enter into the blood, it must be in its water-soluble form. But if a drug must enter the cell, at a cell, okay, if a drug must enter a cell, it must exist in its lipid-soluble form. Lucky for us, most drugs are in their weak electrolyte form. Okay? So hence, class, the absorption of these drug products into the cell is possible. Okay? Nagagawa siya. Okay? Okay. Next physicochemical factor, class, we have to consider is the partition coefficient of your drug product. So as I've told you a while ago, class, most drugs are weak electrolytes. Right? And ang properties, class, ng weak electrolyte is that it is partially ionized and it is partially unionized. So meaning it's partially water soluble and it's partially lipid soluble. Okay? So correct? Okay. Now, since most drugs are weak electrolytes, so their solubility, class, would greatly depend on the pH of the solution where they are being dissolved in. Okay? So pH plays a vital role here. As you all know, if it's a weak acid, the more acidic a solution is, the more likely the drug becomes lipid soluble. The more basic the solution is, the solution where you dissolve your weak acid, okay, the most likely the drug becomes water soluble and thus ready for excretion. So I hope you still remember, class, your Henderson-Hasselbalch equation. Hindi discuss natin sa physical pharmacy. But anyway, so class, most drugs are weak electrolytes, so they're partially water soluble, partially lipid soluble. Now, the question na lang, class, would usually be, saan mas soluble ang gamot ko? Okay, sabi ko nga sa isang review class ko ang usual na katanungan lang na tinatanong dyan, parang sa bata lang. Okay, sino mas mahal mo? Si mama o si papa? So, kung sa gamot naman, sino mas mahal niya? Water or the lipid? Kasi, alam natin ang gamot, partially water soluble, partially lipid soluble. And so, we want to find out saan mas mataas yung kanyang affinity. Would it be the lipids or would it be the water? Or the, water. Okay? So, hence, class, we have the partition coefficient, the apparent partition coefficient. So, this apparent partition coefficient, class, tells us saan ba siya mas soluble. Kasi, class, the partition coefficient determines the ratio of the solubility of the drug at equilibrium, okay, in a non-aqueous and aqueous solvent. So, it measures the relative affinity of the drug to two immiscible solvents. Make sense? Okay, kasi syempre gusto ko rin malaman saan ba siya mas soluble. Sa tubig ba talaga o sa lipids. Okay? Okay, so class, the usual non-aqueous solvent na ginagamit natin here is octanol. And for the aqueous solvent, it's going to be water at pH 7.4. Question, bakit 7.4? Bakit pH 7.4? Bakit hindi pH 7 or any other pH? Okay, anyone? Bakit nga ba pH 7.4? Ano bang meron sa pH 7.4? Bakit hindi pH 5.5? Right? Yes, Miss Pihoto?
Hello po, sir. Try lang po, sir.
Sure.
Kasi po, yung pH po ng blood po natin is around 7.35 to 7.45. So, yung pH 7.4, close po siya sa pH po ng blood po natin, which is slightly basic. Ganun po.
Alright. Thank you so much. So, tama yung class. Actually, class, ano ba ulit ang goal ng gamot natin? Ano yung goal ng mga gamot natin? Siya ay makarating sa?
Sa blood po.
Sa blood. So, therefore, class, ano ang solvent na dapat ko lang i-consider when designing a medicine? It should always be the blood. Okay? So, alangan naman totoong blood ang gamitin ko dito, right? So, therefore, class, we try to replicate na lang because we know that the pH plays a vital role in solubility of a drug, okay, in its existence as a ionized or in its an ionized state. So hence, class, we need to control the pH of your solutions, of your solvents. So hence, class, pH 7.4 ang ginagamit because it is the pH of the blood. Okay, tama yun. And it's not only the pH of the blood, we consider this to be the biologic pH. Okay? So tama yan, Miss Kabalan, Miss Melody. So this is the biological pH. This is the pH of the blood. Okay? Kaya siya yung gagamitin natin talagang pH. Right, so what happens, class, during a apparent partition coefficient experiment? So normally, class, we put two solvents, so water and octanol. And obviously, class, octanol is much lighter than water, so it tends to float on top of water. Okay, and they are immiscible. Now, kasi ang gagawin ko lang dyan is ihuhulog ko yung tablet ko sa solution na to. And then, give it time until equilibrium is reached. Remember equilibrium? Okay, distributed na yung mga particles ng gamot natin. So, alam naman natin, class, na ang mga gamot natin are weak electrolytes. So, it contains water-soluble molecules and it contains lipid-soluble molecules. Okay? So, the blue molecules would mean the water-soluble parts. And then the red molecules would be the lipophilic part. Okay? So, obviously, class, at equilibrium, saan pupunta yung mga red molecules natin? Okay? At equilibrium, saan siya pupunta? Pupunta ba siya sa octanol or pupunta siya sa water? Yung lipophilic part ng ating medicine. Okay? Yes, Mr. Nesho?
Yung red po mapupunta sa octanol.
Okay, very good. So definitely, class, because it's lipophilic by nature, it's going to go to the octanol. Very good, everybody. Okay, and then obviously, class, the water-soluble parts of that drug, okay, will go naman to the water at pH 7.4. Now, after equilibrium, class, ang next na gagawin ko dyan kasi is, kukuha ako ng sample ng octanol. I'll get a sample here. Let it undergo HPLC. Okay, kukuha rin ako ng sample dito, papa-HPLC ko rin yan, to determine the total concentration of drug in each solvent. Now, if after performing HPLC, after determining the concentration, class, in both solvents, nalaman ko na 80% ng gamot ko pumunta sa water. Anong masasabi ko? What can I conclude from that? Yes, Ms. Pihoto.
We can conclude that the drug is hydrophilic.
Very good. Okay, so correct. So now, class, since I know that the drug is hydrophilic kasi most of it went to the water, then I can predict, class, its release mechanism. I can assume na mabilis itong marirelease sa loob ng katawan ko because it's highly hydrophilic and it will have a faster dissolution. Now, if after performing HPLC, class, most of the drug went into the octanol, then I can therefore conclude that my drug is mostly lipophilic. Okay? And if it's lipophilic, class, then I could say that it's released slowly from the body. It will have a slower dissolution, and most likely, class, it's going to be stored in the fats of my body. Sa adipose tissues ng body ko. Because it's relatively lipophilic. Okay? Okay. Next one, class, let's talk about the physicochemical properties. But this time, let's talk about the chemical properties of our medications. So we'll be discussing about the extent of ionization, salt formation, polymorphism, hydrates, and complex formation. Lucky for us, okay, in physical pharmacy, we've already discussed the extent of ionization. Okay? So sabi nga natin, class, most drugs are weak electrolytes, but to be more precise, class, they are weak acids. Okay? So it can either be a weak acid or a weak base and can exist in the either its ionized or unionized state. Now, alam naman natin, class, na ang ionized state would be the soluble sa anong ionized state. If a drug exists in their ionized state, it will be soluble in?
The water po.
Very good. It's soluble in water. At ano yung expected fate ng gamot ko? Absorb or excrete?
Excrete po.
Very good. Expected natin may excrete siya. And if it's in the unionized state, okay, sabi natin it's lipid, it's soluble in the lipid, and hence it is expected to be absorbed in the cell. Now, kayo ba nagturo sa akin ito or may other review class? Okay? Ang sabi na sa akin, once na naging ionized yan, ang mnemonics daw dyan is hype. Okay? Tapos pag yan ay nag-exist in its unionized state, okay, ang mnemonics dyan is lunar. Okay? Ano yung hype? Oops. Asan na yung aking mouse? Right, sasabi na hype. Ano ba ito? H2O soluble, ionized, polar, excrete. Okay, yan daw yung hype. Pag lunar naman, lipid soluble, unionized, non-polar, absorb, or reabsorb. Okay? Sa inyo ko ba ito narinig or sa ibang estudyante ko narinig? I really can't remember. Right? Ayun, hydrophilic, ionized pala. Oh, hydrophilic, tama nga. Tapos isa lipophilic. Okay? Ba't ba H2O soluble agad sinulat ko? Okay, thank you very much. It's hydrophilic. Ito naman, lipophilic. Okay? Thank you very much, Miss Bulanon. So, yun. So, the ionization of the drug depends on its pKa and pH. pKa class, ano nga ba itong pKa na to? What do you remember about pKa? It is the kasi pH. Ito yung pH ng solution. Concentration, acid strength, pwede rin, I guess. Okay, it's a constant value, correct? Okay, sige, hanyo na nga. pKa class is the dissociation constant. Right? It's the dissociation constant. Di ba remember class when we discussed before pH, ang sinasabi ko lagi sa pKa is that it's like the, what do you call this? It's, it is the, para siyang yung neutral pH ng ating substance, ating drug substance. Okay, kumbaga, which is unique for that drug substance alone. Right? Anyway, so the rate of drug absorption is directly proportional to the concentration of the drug at absorbable form, but not the concentration of the drug at the absorption site. Okay? So, kumbaga class, when we talk of extent of ionization, okay, the rate of absorption is highly dependent on whether or not the drug will exist in its ionized or unionized state. So, ano yung absorbable form? Di ba yung unionized state? Okay, that's to be absorbed into the cell. Okay? And not necessarily in its absorption site. Now, state of ionization, as we mentioned before, depends on the pKa of the drug, which is the dissociation constant, and the pH of the solution. So, a drug that is more ionized, is more water-soluble, so on and so forth. Okay, hindi ko na discuss yan. Okay, alam na natin to. Now, sabi nga natin, class, if the solution is highly basic and you put a weak acid substance in there, what will happen to the drug? It will exist in its what form? Ionized or unionized? Okay? If a weak acid drug is exposed in the basic environment of the intestines, it will exist in its what form? Ionized or unionized? So we have an answer here. Okay? Unionized. Okay, isa lang magsasagot. Okay, baka meron pang gustong sumagot. Alright. May nagsabing unionized, may nagsabing ionized. Miss Pihoto says ionized. Okay. Anyone else? Tatlo pa lang kasi ito eh. Okay. Sige, class. Mukhang babalikan natin ng konti yung topic na to. Alright. Class, how do we form the ionized states of our chemicals? Pag sinabi nating ionized, ibig sabihin, hiwalay ang positive. Kumbaga, may distinction between the positive and negative charges of the substances involved. May distinction. Okay? Now, how do we form ionized substances? It's the combination of A. Well, first, it would be a combination of a substance with a positive charge and a substance that has a negative charge. Okay? Now, in terms of extent of ionization, class, okay, if I combine an acid plus a base, ano ang mabubuo ko? Okay?
Ionized solution.
Very good. Alright. Pero tama, ionized ang mabubuo nating substance. Pero anong substance yung mabubuo natin? Okay. Starts with letter S.
Salt po.
Ayun, okay.
Sabay po.
Kadalasan ano eh. Tama naman, ionized naman talaga siya eh. Pero the first substance that we form is a salt plus a byproduct of water. Now, salt here, class, exists in its ionized state. So, sabi natin, class, di ba? Salts or ionized states, water-soluble, lipid-soluble, excrete, hype. Hype natin, yung most set na hype. Okay? So, correct. Now, what happens, class, if ang combination ko is acid plus acid? Acid drug in an acid environment or vice versa. Yeah. Acid drug, acid environment. Okay? Yes, Mr. Nesho.
Ma-absorb po siya. Unionized po.
Very good. Okay? Kasi class, technically, if I combine an acid and an acid, walang mangyayari dyan. So, there will be no distinction between its positive and negative charge. Kasi kung acid-acid yan, parehong positive ang charges niyan. So, therefore, it will not be ionized. Kasi again, ang keyword class sa ionization is my distinction between a positive, there's a combination of a positive and a negative charge. Hence, you form ions. Okay? So, kung acid-acid, parehong positive, wala tayong mabubuo. So, it's ionized. So, dito ngayon papasok yung mnemonics natin na lunar. So, kung base and base, same banana. Ionized. So, balikan natin ng question. I have here with me a weak acid substance exposed in the basic environment of the pH. What will be the fate of this drug, of this weak acid? It's going to exist in its very good. Alright? It's going to exist in its ionized state. Hence, it's going to be more water-soluble. It's going to be excreted from the body. And the same thing, class, if I have a weak base substance in an acid environment, okay, base, acid, alright? So, same banana, it's going to exist in its ionized state and thus be eliminated from the body. Okay? Now, what about this one, class? I have here a weak base substance exposed in a basic solution. Okay? Ano mangyayari sa kanya? It will exist in its what form? Ionized or unionized? Very good, everybody. Okay? So it becomes unionized, so it becomes lipid-soluble. It's going to be absorbed into the cell. Alright? Gusto ko lang Gusto ko talaga islas lagi yun eh. Kasi pag siya unionized, mas mabilis siya ma-absorb into the cell. Okay, not necessarily sa blood. Kasi para sa blood, kailangan siya ay water soluble. Okay, the same thing class for a weak acid substance in the acid environment of the stomach is going to exist in its unionized state. No, kasi ang sabi natin dito class, if a drug exists in its ionized state, remember class that the cell membrane, balik tayo. Okay? That the cell membrane is mostly made up of lipids. These are lipids. These are lipids. So therefore, a water-soluble substance cannot cross it because it will just simply be bounced off. Okay? Palulundagin lang siya kumbaga ng oops. Okay, yeah. Palulundagin lang siya ng ating lipid membrane. So it will be repelled by the lipid membrane. So unlike class, if a drug exists in its unionized state, it will just easily cross the lipid membrane because we say like dissolves like. Kaya na-absorb class yung mga unionized substances. So sabi nga natin class, this is the ion trapping theory. Okay, ito yung theory of ion trapping. Okay, now class, for the Henderson-Hasselbalch equation, it describes the relationship between ionized and unionized forms of a drug. We've already established class that pH of a solution greatly dictates whether or not a drug will exist in its ionized state or unionized state. Correct? Tama ba? So, very dependent class ang water solubility or lipid solubility ng isang gamot sa pH ng solution kung saan siya tutunawin. Okay? So, mahalaga class na kailangan natin lagi i-consider ang pH ng solution and of course, at the same time, yung pKa ng gamot, yung kanyang dissociation constant. Okay? Okay, kung naalala nyo pa class, alright, let's try this one. Sabi natin class, pKa is dissociation constant. While the pH is that of the solution. Now class, for lack of better term, pKa is considered to be, para sa this is just my term. Okay, para mas mabilis natin naiintindihan yung pKa. pKa class is like the neutral pH. Okay, I'll put quote unquote, ako lang nagsasabi niyan. Okay, not anyone else. You won't find that in other textbook. Okay, is the neutral pH of a specific chemical. Okay? Kanya lang yon, neutral pH niya lang yon. Okay? So that is the neutral pH of that specific substance. Okay? Kumbaga, yun. Anything above it becomes basic, anything below it becomes acidic. So the normal pH scale, okay, in our pH scale, di ba sabi natin class, ang neutral pH is 7. Anything above 7 hanggang 14 yon is considered to be basic. Anything below 7 hanggang 1 would be acidic, correct? That's the normal pH scale. That's how we determine the acidity or basicity of a solution. However, class, considering the pKa, okay, this is drug specific, pKa serves as the neutral pH for that specific drug. Alright? So, meaning class, any pH above the pKa for that specific drug is already basic para sa drug na yon. Okay? Any pH of a solution below the pKa is acidic for that specific drug. Okay? Are we clear? Alright, tandaan nyo yung concept na to, Okay, so let's have here an example, class. Well, just so you know, class, a dissociation constant, that is the pH in which, okay, a drug starts to dissociate into its positive and negative charges. Okay, naghihiwalay na siya into ions. Okay? So let's say, for example, class, for aspirin. Aspirin has a pKa of 3.5. Okay, aspirin has a pKa of 3.5. It was exposed in a solution whose pH is 5. Okay? Technically speaking, class, ang solution na ito is what? Acid or base? Based on the pH scale.
Acid.
Very good, Ms. Pihoto. Okay, para sa, based on the pH scale, okay, this solution is an acid. Kasi ang pH niya is 5. Right? Based on the pH scale. Sabi natin, 7 ang neutral pH eh. Pero, okay, para sa aspirin, for aspirin, ano ang solution na to? Acid or basic?
Basic.
Basic.
Very good. For aspirin class, this solution is already basic. Okay? Why is it basic? Because it's above its pKa. So, if aspirin class is exposed to a solution whose pH is 5, ano ang ine-expect natin na mangyayari kay aspirin? Absorb or excrete?
Absorb.
Absorb. Absorb?
Ay, hindi. Excrete ko pala.
Sige nga, Ms. Piyoto.
Ionize po
Bakit
pala.
excrete? Tama ka doon.
Kasi po, mag-form po ng salt or ionize.
Very
Magiging
good.
ionize po siya.
Okay, remember class, aspirin is a weak acid. Okay, hence its pK is 3.5. And since this is acid, tapos para kay aspirin, a pH of 5 is already basic. So, acid, base, you get ionized. So, therefore, it will be excreted. Make sense? Okay, what about this one class? Let's have an example for weak base. Okay, let's have morphine. Morphine class has a pK of, was it 8.8 or 8.5? Hindi ko sure ha. Sabihin lang natin 8.8. Okay, has a pKa of 8.8 and was exposed to the blood. Anong expected natin na mangyayari sa kanya? Absorb or excrete? Okay. Ms. Pihoto says absorb. Okay. Buti ko class ha. Okay, so Ms. Bulanan says also absorb. Ms. Javines also says absorb. Okay, absorb. Alright. Sige, tingnan natin ha. Okay, class. Ano ba ang pH ng blood? What's the pH of the blood? It's 7.4. So, our drug class is a base who has a pKa of 8.8. Now, for morphine, okay? So, for morphine class, okay, a pH of 7.4 is what? Acid or base? Acid. Very good. Acid na para sa kanya to, right? So, therefore, class, will it be absorbed or excreted? Okay, very good, Mr. Nesho. It's going to be excreted. Why? Base ang gamot ko, tapos acid para sa kanya ang blood. So, hence, it's going to exist in its ionized state and therefore excreted. Okay? Nagets ba, class? Are we good? Okay, mag-ingat kayo dyan, ha? Right? Kaya nga sabi ko, lagi nyo titingnan yung pKa. Tapos titingnan nyo, una nyo titingnan, anong pKa ng gamot ko? Ang second na titingnan ko, ano ang pH ng solution kung saan siya matutunaw. Then titingnan mo kung acid or basic ba yan para sa gamot na yun. Okay? For that specific drug. Okay? Kaya titingnan natin yung kanyang, okay lang yan, no problem. Okay? No problem sa Venus. Right? Titingnan mo lang lagi yung kanyang pKa. Isa pa. Sige, isa pa. Wala na akong maisip na gamot eh. O, drug X ulit tayo. Tara. Drug X. So, sabihin natin klase, drug X is a weak acid na lang. Mas common ng weak acid eh. Okay, so si drug X is a weak acid. Sabihin natin class, ang pKa niya is 4.3. Okay? Excuse me. Yung kanyang pKa is 4.3. Tapos class yung solution, or sabihin natin, wag ng solution, maiba naman tayo. Okay? Ang current urine, alright? Ang current urine pH, ang pH ng wiwi is 2.4. Anong ma-expect ko sa gamot na to? Will it be reabsorbed or will it be excreted? Okay? Alright. 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 Okay. So, yung question ko is reabsorb, ha? Pero sige, okay lang yan. I mean, I think you get what we mean naman. Kahit isulat yung absorb. No problem. So, correct class, it's going to exist in its unionized state. Hence, the drug will most likely be reabsorbed back into the systemic circulation. Kasi urine na yung pinag-uusapan natin dito. Okay? Pag urine kasi, di ba yun yung point of exit na ng katawan? So hence, it will either be fully excreted or it will be reabsorbed back into the systemic circulation. So the correct term here would be reabsorb. Okay? Pero kung sakali sinagot nyo yung absorb, okay lang. I mean, nagets ko naman yung ano nyo dyan. Okay? So, pKa of 4.3, it's a weak acid. Now, ang pH of 2.4 is lower than 4.3, right? So this is an acid for drug X. So acid plus acid equals unionized, and hence it's gonna be reabsorbed. Okay, because we're talking about the urine here. All right. Goods. Okay, very good. I know nakakalito siya, class, pero ano ba? Ganun talaga eh. Okay, you really need to understand this, the concept especially. Okay, see, walang memorization dito, class. Okay, it's just understanding the concept behind this. And therefore, mapipredict mo na, class, kung ano yung pwedeng mangyari sa gamot natin. And that is what we do here in pharmacokinetics. By pharmaceutics and pharmacokinetics, we predict, we assume what will be the fate of our drug inside the body. Okay? So it makes sense naman, right? Ayun, sorry, may question. Yes, Miss Savines.
Sir, curious lang po.
Yes.
Parang napansin ko lang po. Pwede po kaya na parang ang clue po doon is, kanyari po, pH is greater than pKa.
Yeah.
Meaning, excrete po siya. Tapos pag pKa is greater than pH, ma-absorb siya. Pwede po kaya na ganun, sir? Or,
Pwede, pero you have to remember, is the drug a weak acid or a weak base? So, kailangan mo lagyan ng label pa rin. Okay, pero pwedeng gawin yun. Kasi kung weak base naman siya, it will be the opposite. Okay?
okay po, sir.
Ayun. So, no problem.
Thank you,
Pwede
sir.
naman yun. Goods na goods tayo dyan. Kasi class, if you remember also, dito sa ating Henderson-Hasselbalch equation, okay? Kasi iba yung formula for weak acid, iba rin yung formula for a weak base. Yes, Miss Bulanon.
Sir, bale po, just to clear things, sir. Kapag acid and base siya, excretion for excrete. Then, kapag parehong base and parehong acid, absorb po. Tama po ba?
Pwede na yun. Okay. Well, we can use that as a benchmark. Yes.
Okay, thank you po.
Alright. Okay, yun lang laging abangan eh. Kaya don't worry, class. Kasi kahit sa board exams or kahit saan naman, lagi naman indicated na kung weak base or weak acid naman yung isang gamot. And actually, class, looking at the pKa, malalaman mo naman kung weak acid or weak base siya eh. Okay? Kasi normally, class, pag weak acid, it's never gonna go beyond 7. Okay? If it's a weak acid. If it's a weak base, it will never go below 7. Okay? The pKa will never go below 7. So, kahit ibigay lang sa inyo ang pKa, you can actually know kung siya ay weak acid or weak base. Pero, again, in most of my quizzes, in most of my exams, even in the board exams class, okay, lagi naman sinasabi kung weak acid or weak base yung gamot ninyo. Right? So, for weak acids class, sabi nga natin, ang formula niya, right, let's have another screen here. White screen tayo. Okay, in Henderson-Hasselbalch equation, so for weak acid, okay, versus weak base. Okay. Ang formula kasi class for a weak acid is pH equals pKa plus log, tama. pKa plus log, okay, Ionized over unionized. Unionized. While for a weak base, its pH equals pKa plus log unionized over ionized. Okay? So class, bakit ganito ang formula ng weak acid versus a weak base? Right? Now, if you notice class, right, yung ratio between the ionized and unionized species, right, is may may relation siya with pH. Now, question, ano ang relationship? Pag sabi ko relationship, hindi yan single or married, mga ganun. Okay, ano ang relationship class ng pH sa ionized species, number of ionized species ng isang weak acid? Is it directly proportional or inversely proportional? Based on the formula for a weak acid. Okay, looking at the equation here, ano ang relationship ng number of ionized species sa pH? Are they direct or indirect? Yes, Mr. Nesho.
Direct po.
Okay, very good. And what about, tuloy mo na Mr. Nesho, what about the unionized species?
Indirect po.
Okay, indirect, sorry, not indirect but inversely. Sorry.
Inversely po pala.
Inversely proportional. Okay, so tama yun class. Ibig sabihin, if there is an increase in pH, if the pH of, if the pH of the solution increases, anong nangyayari sa number of ionized species ng isang gamot? Tumataas. At anong mangyayari sa number of unionized species niya? Bumababa. Okay? Pero again, class, dependent pa rin yan sa pKa ng gamot. Kasi, whether the pH is high or low depends on the pKa of your drug. Okay? Kaya nga sabi ko sa inyo, para siya yung neutral pH ng gamot itself. Alright? Are we good? Yes, Miss Felicity, sorry. May question? Okay, Felicity San Antonio? May katanungan ba tayo? Open queue. Okay, baka nakalimutan lang siguro ibaba ni Miss Felicity. Kinibumbog lang. Okay? So anyway, so yun na nga, increase in pH class, whether or not a pH is high or low will always depend on the pKa of your drug. Are we clear? So, kung sabihin natin class, ang pKa is 4.3, tapos ang pH niya is 5, then obviously class, the pH is already high for this specific drug, correct? It's going to be high for this specific drug. So therefore, mas marami ang ionized kesa sa unionized species na mabubuo. So meaning, the drug will be more water-soluble than lipid-soluble. So nagets? Okay.
Yes, please.
All right. Very good. And same thing, class, will be for weak bases. Okay, again, pKa is your benchmark. So if there's an increase in pH, since it's a base, all right, if the pH is higher than the pKa, which makes it more, napindot lang ba? Sorry. No problem, Miss Felicity. Okay? So kung the pH is higher than the pKa, so therefore, it's going to be more basic for that drug. So hence, class, tataas yung unionized species. Mas magiging unionized yung gamot as compared to its unionized. So, ibig sabihin, yung gamot ko most likely will exist in its lipid-soluble state than its water-soluble states. Okay? Okay. Yun lang naman siya. Oops. So, that's why, class, for weak acids, if pH is lower than the pKa, then it's relatively unionized. If it's higher, then it becomes more ionized. And you know the drill. Hype. Okay? And lunar. Same goes for weak bases. Right? So, class, if you still remember, class, balik. Okay? How do I know if a drug is a weak acid or a weak base? Based on its salt form. Let's say, for example, class, phenobarbital sodium. Gawa tayo muna ng examples, lidocaine HCl. Penicillin potassium. Okay. Looking at the salt form of the drug class. Question, is phenobarbital an acid or a base? A weak acid or a weak base? Si phenobarbital. So alam ko lahat ito ay salts. Okay, they are salt form of the drug. So question, class. What is phenobarbital? A salt, is it an acid or a base? Is it a weak acid or a base? Weak base. Just looking at the salt form.
Acid po.
Alright, Ms. Pihoto, how did you arrive to that conclusion?
Yung phenobarbital po, weak acid. Kaya po siya kinonbine po sa mga salts po. Para
Okay.
po maging ionized po sila.
Alright. Okay, so tama kayo dyan, it's a weak acid. Pero I guess, nga naman, alam niyo naman na weak acid to, right? Pero class, just looking at this kasi, okay, hindi ko ba naturo to last time? Or baka nakalimutan na lang din siguro. Okay, anyway, class, just by looking at this, okay, looking at this, phenobarbital sodium, I can know, class, whether or not phenobarbital is an acid or a base simply by looking at what salt was attached to it. Okay? In this case, class, sa phenobarbital, sodium ang naka-attach, right? Ano ba ang sodium? Sodium is a? It's a base. Very good. It's actually, class, an alkali earth metal. Group 1A. Di ba sa ating, sa ating periodic table, so it's alkali earth metal. So it's a metal. And metals are usually basic. Okay? So dahil base siya, edi obviously, dahil salt yan, di ba? Ano ba ang salts? It's a combination of an acid plus a base. So I know that sodium is a base. So therefore, automatic, alam ko si phenobarbital is an acid. Nagets ba? O, try natin, class. Lidocaine HCl. Ano si lidocaine? Okay?
Base po sir.
Very good. So lidocaine, class, is a weak base. Why? Because HCl is an acid. So automatic, alam ko si lidocaine is a weak base. Okay? Or what about penicillin potassium? Potassium is similar to sodium, right? Okay, it's a metal, so it's a base. So automatic, alam ko si penicillin is a weak acid. So are we clear? Are we good? That's how you find out, class, whether or not a drug is an acid or a base using their salt forms. Okay? So why do we make, class, drugs into their salt forms? Bakit tayo may mga penicillin potassium, lidocaine HCl, morphine sulfate? Okay, bakit may ganun? Because, class, by making a drug in its salt form, we can actually change its physical properties like its dissolution, bioavailability, and its duration of action. Excuse me. So, kaya nating baguhin yun. Amazing, isn't it? Right? So, class, by changing these things, all right, by changing the salt form, we can change the characteristics of our medications. Like, say, for example, for weak acids, okay, for weak acids, class, pag gagamit tayo ng monovalent cations like potassium and sodium, it makes it more water soluble. So, pag more water soluble, increase ang dissolution. At pag increase ang dissolution, increase yung absorption. As compared, class, to using trivalent cations such as aluminum. By using trivalent cations, class, it makes it less water soluble. So, less dissolution. So, less yung absorption. Okay? Now, what about for weak bases? For weak bases, class, if you added HCl, sulfate, citrate, gluconate, this would increase water solubility. And, class, if you use naman estolate, naphthalate, or stearates, these are the salts naman that decreases water solubility. Now, class, why would I want to decrease water solubility of some medications? Sa tingin nyo, why would I opt to reduce its water solubility? Bakit nga ba? Okay? Anyone? Yes, very good. Okay? Pwede yon to reduce the excretion of the drug by reducing its absorption. Para dahan-dahan siya papasok sa katawan, dahan-dahan lang din siya lalabas. Okay? And of course, to delay its effect. We want to delay, or in short class, we want to prolong the effect of the drug. Maintain the effect of the drug. Take that. Alright? Does that make sense, class? Kasi normally, class, pag halimbawa, erythromycin estolate, normally, ang dosing na lang ng gamot na yan is once daily. Wherein erythromycin is usually taken twice daily. Okay, so it reduces your dosing frequency. So that's one of the times wherein you want to delay a drug's absorption by slowing down or by reducing its water solubility. Kaya nga sabi ko, not all the time gusto nating mataas ang water solubility ng gamot natin. It depends on what are my goals. Okay? What are the therapeutic outcomes I want to achieve? Kaya nga part of the biopharmaceutic design or the drug product design is what's the therapeutic outcome that you're trying to look for. Okay, yung mga pharmacodynamic considerations natin. Alright, amazing, isn't it? Okay. So, sige, konti na lang naman to. Tapusin na muna natin to. So, polymorphism. So, sabi ko sa inyo, class, it's the ability of a drug to exist in more than one crystalline form. And between amorphous and crystalline form, okay, mas maganda, class, ang amorphous because amorphous forms have low melting point and have higher dissolution rate. Okay? Mas mabilis silang mag-dissolve. Compared to the crystalline kasi mataas ang melting point. Ibig sabihin, matagal siyang matunaw and therefore mababa ang dissolution rate. Okay? So, amorphous forms of the drug class have faster dissolution. Okay, ito naman, maganda itong question eh. Hydrates, in terms of hydrates, which one will have a faster dissolution? Hydrous form or anhydrous form? Okay, nakasulat na pala dito. Sige, never mind. Anhydrous form of a drug class will have a faster dissolution as compared to their hydrous form. Pero why? Why do you think so? Tingin nyo, bakit mas mabilis mag-dissolve or mas mabilis matunaw sa tubig yung anhydrous kesa sa hydrous forms? Okay, anyone? So, sige, hanyo na. Okay lang yan. Okay? Now, class, allow me to explain. Pag hydrous na kasi, class, ang gamot, isipin nyo lang ganito. Pag ang hydrous nga pala, class, means the compound already contains water in its structure. Like, say, for example, C6H12O6 na lang. C6H12O6, which is glucose. Tapos may the 2H2O. Okay, pag ganyan, class, ang equation, this is hydrated form. Pag yan ay C6H12O6 lang, that's the anhydrous form. Ibig sabihin, wala siyang water molecule. Now, class, yung anhydrous form, mas mabilis matunaw sa tubig kaysa sa hydrated form. Bakit? Isipin nyo lang parang ganito. Okay, yung anhydrous, tama yun, Miss Bulanon, wala siyang water eh. Kumbaga, siya yung pinakasabik sa tubig. Kaya pag na-expose niya sa tubig, welcome niya lahat ng tubig na makita niya. Kaya mas mabilis siyang matunaw. As compared to the hydrous form, may tubig na siya eh. Kumbaga, sanay na siya sa tubig, so hindi siya ganun ka-excited makakita ng tubig. Alright? Nagets ba, class? Pero in reality, class, the proper explanation for this one actually is more of its molecular weight. Okay? Tinatamad na ako mag-compute pa isa-isa. Hanapin ko na lang. Okay. Hanapin ko kay Google. Ano nga ba molecular weight ni glucose? Glucose. Molecular weight. Glucose. Molecular weight. 180. Okay? Ibang color naman tayo. So, glucose class has 180 grams per mole. Okay? So, 180 grams per mole ang molecular weight ni glucose. Now, class, kung yan ay hydrous form, magdadagdag ka pa dyan ng, ng molecular weight ng water, which is 18. So, that's 36, 216. Tama ba ako? Tama. 216 gram per mole ang molecular weight ng hydrous form ng glucose as compared to its anhydrous form. So, in terms of molecular weight kasi class, the higher the molecular weight, lesser ang solubility. So, hence, solubility in water. Alright? So, hence class, looking at the molecular weight alone, mas mataas ang molecular weight ni hydrous form kesa kay anhydrous. So, therefore, class, lesser ang water solubility niya. Nagets ba? Are we good? All right. Excuse me. Okay. So are we good? Okay. So let's proceed. Now, class, let's talk about the drug complex formation. Okay. So, for drug complex formation, class, complex of drug molecules can't cross the natural membrane barriers, and they render the drug biologically ineffective. Okay. A usual example, class, of a drug complex formation would be protein binding. Okay, that's a drug complex formation. It's a complex between a drug and the protein albumin. So it can render drug biological effects to be ineffective. All right, makes it ineffective. So the rate of absorption is proportional to the concentration of the free drug molecules, i.e. the diffusion of the drug. And due to the reversibility of the complexation, equilibrium between free drug and drug complex occurs. Okay? So complex can reduce the rate of absorption of a drug but not affect the availability of the drug product, which is true. Okay? So complexation can reduce the rate of absorption but not the availability of the drug. So again, class, an example of this would be, the usual example discussed would be protein binding. So basically, class, here are some of the physiological factors that basically affects drug absorption. So we start off, class, with cell membrane. Okay, as you all know, one of the important things, class, na kailangan magawa ng gamot natin ay makapasok siya sa ating cell membrane. Okay, because some of the target sites or the receptors of our drugs, okay, nasa loob ng cells. So therefore, class, we have to take into consideration the cell membrane and its properties. At ano nga ba, class, ang isa sa mga pinaka-significant property ng ating cell membrane? Because our cell membrane is semi-permeable and it is soluble to what type of solutes? Okay, so sabi natin, it's semi-permeable. Ibig sabihin, pili lang yung nakakapasok sa kanya. And it allows solubility of what types of solutes? Okay, when I say types of solutes, dalawa lang naman usually yon. Okay, is it water-soluble or lipid-soluble solutes? Yun, Miss Pihoto.
Lipid-soluble.
Very good. And thank you, very good also, Mr. Reyes. So sabi natin, it's lipid by nature. Hence, class, allows the permeability of lipid-soluble substances. Okay, then class, next we will be talking about the transport mechanisms, the various transport mechanisms that allows our medications or any product class to enter the cell. We'll be talking about the first pass effect. We'll be talking about surface area. Okay, the absorbing surface area. So, if you remember, class, ang sabi natin, if there's an increase in the absorbing surface area, it also increases absorption. Hence, class, we will be finding out why is it that the small intestines is the major site of absorption for most drugs, especially drugs administered via the oral route. Excuse me. Next one, class, is blood perfusion of the GIT. Okay, now, class, how do you think blood perfusion plays a role in absorption? Sa tingin nyo lang, how does blood perfusion play a vital role in absorption? Okay? Anyone, sa tingin nyo, importante ba yung blood flow? Okay, sa ating GI tract when it comes to absorption?
Yes po, sir.
Sige, Miss Javines, bakit sa tingin mo?
Ano, sir, parang sa visualization ko po, sir,
Okay.
parang po kasi yung blood perfusion, yung blood po natin, siya yung nagiging vehicle nung drug
Very
para
good.
mapunta po dun sa certain organ. Ngayon po, kung mabilis yung blood perfusion, ibig sabihin po parang mabilis din po mapupunta yung drug sa organ. Ganun po.
All right, very good. That's actually that's actually correct. Okay? So class, one of the things that we have to remember is that perfusion class plays a vital role in absorption. In a sense, class, that it improves distribution. Okay? An organ class that has poor perfusion will receive little amounts of a drug or a compound. Okay, whatever enters the blood. Remember class that the blood, serves as a vehicle for transport. Okay? Doon dinadala or doon kinikerry yung solutes, the various solutes in our body, okay, such as sugar, okay, energy, proteins, and so on and so forth. And of course, class, drugs are also transported via the blood. Okay? Sooner or later, during the course of this subject class, you will also learn that blood perfusion plays a vital role not only in absorption but especially in distribution of medications. Because class, perfusion is actually the rate-limiting step for drug distribution. So, an increase in perfusion, okay, blood flow,
Sir,
also increase distribution. Yes.
hindi po ata kayo naka-share screen.
Oh my gosh, talaga ba?
Opo, sir.
Wait. Ah, my goodness, nagsusulat-sulat na ako dito. Akala ko naka-share screen na ako. Whoops! Thank you so much for Alright, ayan. Alright, sorry about that. Hindi pa pala ako naka-share screen. Anyway, pero naka-record na yung screen ko. Anyway. So, ayun class. So, again, increase in blood flow, okay, will technically increase distribution of drugs. And therefore, class, increase also absorption kasi mas mabilis na de-deliver yung medications, yung compounds, yung solutes sa kanilang mga target areas. Okay? The next one, class, is GI motility and transit time. We'll discuss this separately in a while. Okay? And then lastly, class, na pag-uusapan natin about absorption is how does food and drugs affect GI absorption. So we will be choosing specific drugs, class. Okay, just a few that greatly affects GI absorption of other drug products. If you remember, class, we had one discussion last meeting where I discussed about loperamide. How loperamide, tama ba? Kayo ba yun? Anyway, so one of the things kasi, class, that we have to consider here is, say, for example, loperamide. Okay, what do you know, class, about loperamide? Yes, Mr. Nesho.
Pinapababa po niya yung peristalsis po.
Very good. Alright, so kayo nga na-discussan ko nito. So, class, it reduces peristalsis. And we've mentioned before, class, that peristalsis plays a vital role in how much of the drug is absorbed, especially with regards to the extent of absorption. By slowing down, yes, Miss Antonio? Okay, napindot lang siguro. Okay? So, class, pag na-reduce ang peristalsis ng ating tiyan, ng ating bituka, so tendency, class, is mas tumatagal yung gamot or any product in the GI tract. So, class, the longer the residence time, ang tawag natin doon, okay, the longer will be the drug, the higher will be the drug's absorption. Hence, class, loperamide oftentimes is contraindicated with drugs administered orally because of the fact, class, that per oral drugs combined with loperamide improves its absorption to the point, class, na minsan sobrang taas na yung na-absorb. Okay, which leads to, again, toxicities. Okay? So, let's talk about the membrane and its properties. So, sabi nga natin, class, it's a barrier between the morphological and functional units of the cell. Okay? And its property includes its permeability. So, it's semi-permeable. Okay? And the cell membrane, class, is basically made up of lipids. So, very low. Its surface tension is very low due to adsorption of proteins to the outside of the lipid layer. And in terms of electrical properties, class, membrane potential due to different distribution of ions in the ECF and the ICF, or the extracellular fluids and the intracellular fluids. Now, class, you learn more about its electrical properties when it comes to sa pharmacology, especially when we start talking about depolarization, repolarization, hyperpolarization pala muna, and repolarization. You've heard of these terms na ba, class? Itong tatlong term na to?
Yes, please.
Right, familiar na, right? Very good. So, you know, class, that ions, okay, move in and out of the cells via the voltage-gated channels, right? The sodium channels, the potassium channels, then the sodium-potassium pump, okay? And because of those channels, class, it gives our membrane its electrical differences, okay? It allows for the movement of ions in and out of the cell, creating what we call action potentials or membrane potentials, okay? And that's one of the properties, class, of our cell membranes. Now, that property, class, plays a vital role in the pharmacodynamic sides of medications. In terms of pharmacokinetics naman, class, or in biopharmaceutics, ang property niya na siya ay lipid soluble, yun yung pag-uusapan natin dito. Right? Yes, Miss Zapanta.
Sir, sorry po. Pwede pong pabagalan yung...
Sorry?
Pag-discuss. Pwede pong pabagalan, sir.
Pabagalan. Siya namang mabilis ang
Sorry
magsasalita.
po.
It's okay, it's okay. Okay? Now, since this is recorded class, okay, i-upload ko naman sa YouTube, i-slow down yung agad, Okay, just slow down the video, if ever. Pero sige, don't worry, we'll still discuss this in a slowly but sweet manner. Alright? Okay, so again, class, when it comes to the properties of our membrane, right, ang mas pinakapag-uusapan natin dito, class, is its lipid property, lipoidal property, which allows, again, drugs that are lipid soluble to easily enter into the cell. Okay? Now, in terms of its electrical properties, ulitin ko lang, class, mas nidiscuss ito sa pharmacodynamics. Okay? Which is part ng lecture nyo sa pharmacology. Okay? Try lang nga natin, class. Ano nga ba, class, ang nangyayari pag nagkakaroon ng depolarization ang cell membrane? What happens during depolarization process? Yes! Yun, Miss Pihoto.
Rinig po ako, sir.
Medyo maano, pero sige, lapit mo ng konti yung mic.
Ito po, sir. Okay na po.
Sige, pwede na rin. Narinig ko naman.
Sorry po. Sige po, lakasat ko na lang po.
Okay.
Sa depolarization po, nagkakaroon po ng action potential po.
Okay.
Yung isang cell po, therefore, charge po siya. Nagkakaroon po ng charge.
Kakaroon charge. What charge would that be? Is it positive or a negative charge?
Ayun po, sir. Positive po siya, sir.
Okay, very good. What about hyper...
Therefore, excite po yung cell po.
Very good. Hyperpolarization.
Dito naman po, sir, negative po yung charge na kasi po, nag-rest na po mismo yung cell.
Alright. And lastly, would be repolarization.
Pagkakaalala ko po sa repolarization, galing po siyang depolarization, pababa pa lang po siya ng hyperpolarization.
Okay.
Pero considered na po siya as negative.
Okay, very good. Actually, class, so tama yun. Thank you very much, Miss Pihoto. So during the depolarization process, class, this is the time wherein sodium enters the cell by the sodium-gated channels. Sodium enters. Okay, which makes the cell more positive. Kasi if you remember, class, sodium is a positively charged ion. Hyperpolarization happens naman, class, when potassium channels open. Okay, potassium channels open. What happens ba, class, pag nagbubukas ang potassium channels? Okay, you have to remember, class, whenever potassium channels open, okay, efflux ang direction, ang kanyang direction, efflux. Sodium channels kasi is influx. Okay? So whenever the potassium channel, class, opens, it means it's efflux. So it lets potassium ions leave the cell. Okay? Now remember, class, anong charge ng potassium natin? Is it positive or negatively charged?
Positive.
Very good. It's very good. All right? It's positively charged. Now, class, since it's positively charged, now it leaves the cell. Iiwan niya ang cell natin. Ano mangyayari ngayon sa charge ng cell natin? Bababa. Or, sabi nga natin, it's going to become more negative because your cell is losing positive ions. Kaya, class, nangyayari is nagkakaroon tayo ng hyperpolarization. Remember, class, yung concept ng piso? In potassium in,
Yes,
sodium
po,
out.
sir.
Yun, very good. So potassium will always be inside the cell. Sodium will always be outside the cell. That's the normal state of the cell. Okay, pero during an action potential, class, sodium enters the cell, potassium leaves the cell. So nagkakaroon ng pagbabaliktad sa sequence ng ating mga ions. So therefore, class, we have to bring it back to normal. Hence the purpose, class, of repolarization. Repolarization, class, involves your sodium-potassium pump. Okay? What sodium-potassium pump does is the excess amount of sodium that entered the cell is being pumped out, while the amount of potassium that was already pumped out of the cell is being returned back sa ating cells, sa loob ng ating cell. Okay? In a ratio, class, if I'm not mistaken, is 3:1. Parang 3 ions of sodium is being pumped out, while 1 ion of potassium is being pumped in the cell. Now, class, since marami ang lumalabas na positive kaysa sa pumapasok, so relatively, class, we maintain the charge of the cell, which is around negative 70 millivolts. Okay? Now, that is the resting membrane potential. Hopefully, you still remember what this means. Okay, the resting membrane potential. Alright, so sabi ko, dapat i-discuss ko sa pharmacodynamics, pero i-discuss na rin natin. Anyway, good to know na lang din. Okay, so, in terms of the permeability of the cell membrane, as I've discussed a while ago, ito yung pinaka-importanting property ng ating cell membrane na pag-uusapan natin sa pharmacokinetics and biopharmaceutics. So, it's first and foremost lipid, it's lipid by nature. So it allows the solubility of lipid solutes. Okay, so hence, class, if your drug is lipid soluble, partially lipid soluble, it can easily enter into the cell via passive diffusion lang. Okay? Now, hindi porket water soluble ang isang gamot, mostly water soluble, ay hindi na siya makakapasok ng cell. Okay, so laging may pag-asa. Okay, kasi, class, ang ating mga water-soluble drugs, okay, can still enter into the cell, okay, via a process known as convective transport. Now, class, when you say convective transport, remember the lipid layer membrane of our cell. Okay, looks something like this. All right. So, class, andito yung mga hydrophilic heads and then the hydrophobic tails. Now, if your drug, class, is water-soluble, kung lipid-soluble muna tayo. If it's lipid-soluble, sabi natin, class, it will just penetrate into the cell, right? Kasi lipid din yung cell membrane. Right? So, technically, like dissolves like. So, it can just easily penetrate into the cell. Now, if your drug is water-soluble, if it is water-soluble, normally, class, it will be repelled by the lipid membrane. Okay? Pero sabi nga natin, class, hindi naman all the time. Kasi, class, even if it's water-soluble, it can cross the tight junctions between the heads and the tails. Sisingit siya dyan. Kayang gawin yun ng drug natin na water-soluble. So, sisingit siya in between the tight junctions. Okay? Or via the water-filled pores inside our cell membrane. Okay? Kasi some of the cell membranes, class, are filled with water molecules. Doon papasok na yung mga water-soluble drugs natin. Okay? And when it enters the cell, class, it can be absorbed via convective transport. Alright? So next one. Substances may combine with a carrier in the membrane and transfer through it as a drug carrier complex. An example of which would be active and facilitated transport. I'll explain this more in a while. Okay, and then solid substances, class, and oil droplets may transfer the membrane in a vesicle. Now, if you still remember, class, vesicular transport via pinocytosis or phagocytosis. Okay, this is the only transport mechanism that does not require drug to be in solution form. Sabi natin, class, diba, pag in solution form ang gamot, it's soluble in what? It's basically,
Blood po.
yes, Miss Savinas?
Soluble in blood po.
Blood. Okay, I'll take that. Soluble in blood or soluble in what solvent? Water or lipid?
Water.
Very good. Okay, di ba sabi natin, class, one of the major requirements for drug absorption is that a drug must exist in its aqueous form or solution form. Or water-soluble form. Okay? However, class, there is an exception to that. If a drug is absorbed via vesicular transport, when we say vesicular transport, that involves pinocytosis and phagocytosis, it does not require the drug to be in its solution form. Okay? Kasi kaya siya, class, ma-absorb into the cell, okay, in its pure state, in its non-aqueous form. Okay, di ba example natin dito, class, would be the vitamins A, D, E, K, the ADEC, which is, of course, known as the lipid, the fat-soluble vitamins. Okay? Okay. So sabi nga natin, class, if a drug is if it's lipid-soluble, it will just simply go along the concentration gradient, okay, and be transported via passive diffusion. Now, do you still remember, class, the concentration gradient? Okay, what does it mean when we say concentration gradient? It's the movement of solutes from an area of to Yun, Mr. Nesho.
Higher concentration po
Very
to
good.
lower.
Okay, higher concentration to an area of lesser concentration. Yes, Miss Krisha? Yun, okay. Sige. Alright, so class, tama yun. So sabi natin, ang concentration gradient is the movement of molecules from an area of high concentration to an area of lesser concentration. Kaya nga, class, kapag magtutunaw tayo ng asukal sa kape, okay, pag hindi mo yan hinalo, class, nasa ilalim lang lahat ng sugar. Okay, tatamis ng konti yung topmost portion ng inyong baso. Okay, pero dito, it's not as sweet as that of sa ilalim because yung sa ilalim ng ating baso, andun yung area of high concentration. But still, class, the solute will move to an area of lesser concentration. So that's passive diffusion. And passive diffusion, class, follows the Fick's law of diffusion. Okay? When we say Fick's law, yun na nga, the movement of the solute molecule from an area of high concentration to an area of lesser concentration. Next one, class, is convective transport. Okay? So, in convective transport, class, ang sabi nga natin dito, water-soluble solute moves across the tight junctions or water-filled pores in the membrane. Right? And one of the driving forces, class, of convective transport is osmotic pressure. Try natin. Anong naalala nyo, class, sa osmotic pressure? What can you remember about osmotic pressure? May ano siya, class, almost similar siya to diffusion, pero may may konting difference. Osmosis, class. What does it mean when we talk about osmosis? Yes, Miss Pihoto.
Hello po, sir. Pagkakaalala ko po, when we say osmosis, talks about only the movement of water po.
Very good. Okay. It's water movement. Thank you very much. Okay. Now, class, paano ba gumagalaw ang water inside our body? Say, for example, class, tandaan nyo to it always involves a semi-permeable membrane. If this is the cell membrane, okay, kunwari, class, andito ang high solute concentration. Palitan natin ng sorry. Let's replace the Ito yung solute. Tapos, konti lang yung solute inside. In, out. Alright. Class, paano magiging movement ng water nito? How will the water move given this scenario? Okay, will it be in to out or out to in? Yung water movement lang. Okay, Mr. Reyes? Okay.
Answer, palabas.
Very good. Paano mo nasabing palabas?
Kasi napagkakatanda ko po kasi sir, pag osmotic pressure, kumbaga, parang yung water, itatry niyang basain yung solutes.
Very
kumbaga, ayun po.
Okay, very good. Alright, so, I'm glad you guys still remember this. Okay, now class, remember, di ba, ano ba ang goal ng water? Ang goal lagi kasi, class, ng water is to dilute highly concentrated solutes. So kung saan mas mataas ang concentration, pupunta doon ang tubig. Okay? And that's usually via a semi-permeable membrane. So therefore, class, ang pressure na ini-exert ng water natin, osmotic pressure, class, refers to the pressure of the water as it moves in or out of the cell. So therefore, class, ang pressure na to would be palabas. Okay? So ang movement niya, pag ganito. So the water here, okay, kunwari ito yung water molecules, yung color green, ang movement niya, class, ay palabas because the water will always try to dilute. Okay? The water will always try to dilute, class, the high concentration of solutes. So kumbaga, wherever the solute is, water will always follow it. Yun lang tandaan natin. Until it reaches equilibrium. Pag at equilibrium, class, ibig sabihin, balance na yung concentration in and out of the cell. Then we say, class, that cell is already isotonic. So therefore, class, the concentration in and out of the cell is equal. Okay? Now, normally, class, kung ito ang movement ng ating water from in going out, right? What happens to your cell? Does it crenate? Does it swell? Or does it remain normal? Will the cell shrink? Yun na lang pala ang term. Shrink, swell, or... Okay, very good. Right? So, very good, everyone. So, correct. It means the cell will shrink. Kaya, ang solution natin is technically hypertonic. Right? Now, class, that osmotic pressure is what drives water-soluble compounds to enter into the cell. Kasi, class, if this is the cell membrane, say this is the cell membrane. Okay. Obviously, class, ito yung out, ito yung inside the cell. Okay? Color green. Okay, assuming, class, ito yung drug molecule natin. Normally, class, mas marami ang amount of drug outside than inside, right? Okay? So, ayan. So, usually, mas marami ang amount of drug outside than inside, or it depends. Okay? Pero one of the things kasi that could drive it to go in would be osmotic pressure. So, halimbawa, class, kung konti lang yung amount of drug here, of solute here, normally, ang pressure ng water, pag ganon. Kasi it will try to dilute it. Pero, class, kung may amount of solutes, mas marami ang amount of solutes inside the cell than outside. So, it forces the drug. Okay? Napipintan tuloy ang drug na ma-push inside the cell because of osmotic pressure. Okay? So, ayun. Pero basically, class, yun. It's just the movement when we say a water-soluble compound enters into the cell. Okay? And the process, class, that it would use, the transport process or transport mechanism it will use will be convective transport. Now, what about active transport, class? Okay? As the term implies, class, it's active, right? And that means it utilizes energy. Okay? Now, class, please take note that both active and facilitated transport utilizes carriers. Okay? Gumagamit sila ng carrier molecule. Ibig sabihin may tagabitbit sila. Now, since it uses a carrier, okay, may tagabitbit siya, will it undergo saturation or not? Okay? What do you mean, class, when we say saturated? Bago ang lahat pala. Okay, what can you tell me about saturation? In your own simple term lang, class, in your own understanding, what does it mean when something is saturated? Okay, like halimbawa.
Parang,
Yes.
Ay.
Yes, Miss Sabinas, go.
parang ano siya, sir? Thoroughly soaked po siya.
Sorry?
Thoroughly soaked po siya.
Thoroughly soak. Okay, I'll take that. Pwede yun. Okay? Parang babad na babad, ano? Pwede. Okay? Madami pong content yung isang solution. Very good. Alright. So, I'll take that also. Okay? Kasi, di ba, pag sa chemistry, di ba, napag-uusapan natin yung saturated versus supersaturated solutions, Actually, sa dosage form, pag-uusapan din natin yan. Now, class, when you say saturated kasi, pag nasa-saturate ng isang system, okay, ibig sabihin, class, siya ay napupuno. Alright? Halimbawa, yung capacity ng isang solution to dissolve a solute, that can be saturated. Okay? To the point, class, wherein if you go beyond its saturation point, any excess amount of solute will no longer be dissolved. Kasi napuno na yung capacity ng solution na yun to dissolve the solute. Does that make sense? Or, ito na lang, class, pinakamadali example ko lagi na, na binibigay. Kaya halimbawa, nag-away kayo ng boyfriend or girlfriend mo. Tapos si girlfriend sasabihin, or si boyfriend sasabihin niya kay girlfriend, alam mo, saturated na ako sa pag-uugali mo eh. Ano ibig sabihin nun? Sabihin, punong-puno na siya.
Pupuno na po.
Napupuno na siya, right? Ibig sabihin, hindi niya na kayang tiisin. Okay, kumbaga, na-reach mo na yung limit, yung limit ng tao na yun, yung pasensya niya. Okay? So that is what we mean, class, when we say saturation. Okay? Ibig sabihin, napupuno yung isang system. Now, think of it this way, class, since both active transport and facilitated transport uses a carrier. Say, for example, ito ang carrier. Sa tingin mo, class, kaya ba itong magbit-bit ng compounds unlimited? Can carriers carry unlimited amounts of compounds? So, no, right? It's a big no. Ibig sabihin, class, carriers can be saturated. Correct? Kasi, class, kung halimbawa, 1, 2, 3, 4, 5, 6, 7, 8. 8 particles lang ng solute ang kaya itong i-carry. Kaya pa ba ito mag-accommodate ng iba? Like say, for example, dagdagan pa ng iilan?
Hindi na po.
Okay, most likely, class, hindi na because it's already saturated. So, the excess amount, class, will not be accommodated by the carrier. Kasi hindi na siya kasya. Okay? Hindi ito katulad ng jeep na pang-sampuan lang, pwedeng gawing pang-15. Okay? 15 yung isasakay lang tao. So, yun. So, therefore, class, both active transport and facilitated transport can undergo saturation. And since it can saturate, class, right, meron kasi tayong equation that best describes saturation kinetics. We call this the Michaelis-Menten equation. Okay, hindi ko nasulat dyan. Equation. Okay, this is the equation, class, that best describes saturation. What happens when a system starts to saturate? Right? Now, I won't be explaining to you guys the Michaelis-Menten equation per se. Okay? Pero, class, I will be discussing to you guys yung tinatawag nating zero-order kinetics, which is the order of reaction that takes place once a system starts to saturate. Zero-order kinetics kasi, class, best explains what happens to a system or ano yung kanyang, yung rate at which it starts to, how do you call this? The rate of the reaction, okay, how it behaves once a system begins to saturate. Okay? Were we able to discuss this, class, during physical pharmacy? First order and zero order kinetics?
Yes, please.
Discuss natin, right? Okay, good.
Yes po.
All right. Oh, that's good. So at least parang review na lang to para sa atin. So remember, class, how zero order kinetics work? Okay, no matter how high the initial concentration is, okay, yung rate at which a drug eliminates or reacts remains the same. Okay? Okay. And if you remember, saturation kinetics normally follows zero order kinetics. Okay, it's best explained via the Michaelis-Menten equation. Now, anong pinagkaiba ngayon ni active transport at the facilitated transport? Okay? So, both of which uses carrier, both of which can undergo saturation kinetics, both can be saturated. Now, the only difference lang naman kasi, class, between active and facilitated transport is simply active transport goes against the concentration gradient, while facilitated transport uses the concentration gradient. So, which of the two, class, uses Fick's law? Okay? Which of the two transport mechanism utilizes Fick's law or can be explained via the Fick's law? Is it active or facilitated transport? Very good. It's the facilitated transport mechanism. Why? Because it goes along the concentration gradient. Okay? And if you go along the concentration gradient class, then it follows the principle of diffusion, wherein molecules are moving from an area of high concentration to low concentration. For active transport class, it goes against the concentration gradient, meaning from an area of high concentration going to an area of, from an area of low concentration going to an area of high concentration. So it's opposite. Right? And if you are going against the concentration gradient class, you need energy. You need ATP. Okay? Let me give you a good analogy of this class. Na-try nyo na bang sumakay sa MRT? MRT, LRT, sa tren. Okay. Good naman, naranasan nyo na, no? Okay? Kahit nasa province kayo, kung naranasan nyo nang lumuwas ng Manila at nag-LRT, okay, siguro naranasan nyo na rin mag-tren. Naabutan nyo na ba ang tren during rush hours?
Yes po.
Yes
Right.
po.
Okay, alam niyo kung gaano ka hectic sa MRT or sa LRT kapag rush hour. Now, think of it this way, class. Think of it this way. Okay? Kung ikaw, class, halimbawa ang laman ng tren, ikaw lang ang taong laman ng tren. Okay? Ikaw lang laman ng tren, ha? Tapos, class, dumating ka sa isang station na punong-puno ng tao. Alright? So, ang loob ng tren has low concentration of people. Outside the train, yung sa station na yun, is full of people, right? So, an area of high and area of low concentration. So, may difference. Now, class, kung ikaw yung laman ng tren at lalabas ka sa station na yun, sa tingin mo, makakalabas ka agad? Okay? Pag binuksan yung pinto, di ba mahihirapan ka? Mahihirapan ka because sasalubungin ka ng lahat ng taong yan. Magmamadali ang makapasok eh. Kasi nakita nila walang laman yung tren. So, class, if you're the molecule, you want to go against the concentration gradient, right? Because you want to go out of the cell. Pero majority of the people are going in. So, if you're going to go against the concentration gradient class, kung gusto mong lumabas ng tren, kailangan mo mag-effort, di ba? Sisikuhin mo lahat ng tao dyan. Excuse me, huwag niyo akong salubungin, hindi niyo ako kamag-anak. Di ba yung mga sasabihin natin? So, class, you're using a lot of energy, right? You're going to use a lot of energy, and that will require energy. Hence, class, going against the concentration gradient requires the use of ATP. Okay? Because, yun nga, kinakalaban mo yung, kinakalaban mo yung flow ng tao. Right? So, I hope that makes sense. Now, facilitated transport. Isipin natin, class, dumating yung tren, walang kalaman-laman. Okay? Walang kalaman-laman yung tren. Tapos, ikaw, class, ang nasa harap ng pila. Tapos, napakaraming tao sa likuran mo. Right? Na, class, kung pagbukas ng pinto ng tren, sa tingin mo, kailangan mo pa mag-effort maglakad para lang makapasok? Kahit hindi na, right? Magpapatangay ka na lang. Okay? Yung mga tao na yung magtutulak sa'yo, papasok. Okay? Wala ka effort, nasa gitna ka na ng tren. Okay? Because you're going with the flow. Okay? You're going with the concentration gradient. Hence, class, there is no need for ATP. Okay? So, I hope that makes sense, class. Class, facilitated transport. Normally, class, a good example of active transport would be the sodium-potassium pump. Okay, yung discuss natin a while ago. And then for facilitated transport, class, an example of this would be how vitamin B12 enters into the cells. Okay, with the use of the carrier intrinsic factor, with intrinsic factors. Okay, ion pair naman, how does this work? It's a complex, okay, wait. It's a complexation between, okay, so it creates a complex of organic anion with a cation of the membrane, right? So, it's like this, class. Ano ang charge ng isang cell kapag siya ay anion? Sorry. Ano ang charge ng isang molecule kung siya ay anion? Is it negative or positively charged? Very good. Yes, Miss Pihota?
Hindi ko nasabi na po, sir. Negative.
Right, so very good. It's technically negative. And a cation class would be positive. Naalala ko ito nung high school ako, tawag ko ito anions and cations. Okay? Only in college, I found out na anions and cations palang pronunciation ito. Alright. Class, a cell membrane is lipid by nature. We know that. Now, since it's lipid by nature, class, ano ang charge ng cell membrane? What is the usual charge of a cell membrane? Since it's lipid by nature, is it positively charged or negatively charged?
Negative po.
Okay. Anyone? Oh, ayun, si Ms. Ramchandani is very good. All right, very good, class. It's negatively charged. Okay, normally negatively charged ang lipid membrane natin. Now, here, class, let's say we have here an anion. This is a drug. Okay, ito si drug X, kunwari. Since it's negatively charged, class, sa tingin nyo, makakapass through siya sa negative charge ng lipid membrane natin? Okay, in terms of charges, class, pag same charges, ang tendency is nare-repel siya, right? Nare-repel. Now, what's nice, class, inside our cell or inside our body, okay, meron tayong mga cations, organic cations, such as mucin. Now, mucin class alone is inert. Okay, it can easily enter into the cell. Okay, mabilis siya nakakapasok sa cell. Now, since it's positively charged and anionic drugs are negatively charged, okay, the anion class can just partner up with the mucin to create what we call a neutral complex. Okay, kasi ang mucin is positive and our anionic drug, anion, is negative. So, pwede silang magsama. At pag nagsama sila, class, ang nabubuo ay isang, we are able to create a neutral complex, correct? It's an ion pair. Okay, an ion pair, may positive, may negative. Okay, now class, pag nag-create na tayo ng isang neutral complex, what's nice about this is, since it doesn't technically have a charge, it can cross the cell membrane. And once it starts to cross the cell membrane, class, pwede na ngayon maghiwalay yung negatively charged anionic drug. Oops. At yung positively charged na cation. Right? So in that mechanism, class, allows the anionic drug to enter into the lipid, into the cell. Right? So dito na sila ngayon maghihiwalay. And the anionic drug can start to target its receptor, while the cation class just stays there. Okay? Does that make sense? Okay.
Yes, sir.
Alright. So isipin nyo na, class, parang user lang yung anionic drug. Ginamit niya lang si mucin para makapasok sa loob ng cell. Okay? And the lastly, class, would be the vesicular transport mechanism. So sabi nga natin, class, vesicular transport mechanism does not require a drug to be in its solution form. Okay, and can allow a drug to enter into the cell in its unchanged form. Okay, in its lipid-soluble state. Now, please take note of these mechanisms are the transport or the absorption of drugs going into the cell. Right? Going into the cell. Kasi most of the time, ang receptors natin, ang target ng drugs natin are inside the cell. Pero class, for a drug to be absorbed into the blood, again, it has to be water-soluble. Okay, so here's a sample, class. Here's what happens during a transport mechanism. So parang summary lang. So sabi nga natin, class, via simple diffusion. Okay, if a drug follows simple diffusion, so it has to be lipid soluble. So it can just go with the concentration gradient. Okay, so for passive transport, pwede siyang gumamit ng carrier or channel. Okay, it goes with the concentration gradient. Now, of course, because active transport, on the other hand, goes against the concentration gradient. So it moves from an area of low to high concentration. And since it's going against the concentration gradient, class, it will need energy. Okay. Here's another representation, class, of how our transport mechanism works. Right? So sabi nga natin, class, pag passive diffusion, it moves from an area of high concentration to an area of low concentration. Okay? Pero class, pag passive diffusion, it doesn't require the use of a carrier. Pag facilitated naman, this one would definitely require the use of a carrier molecule. And when you go against the concentration gradient, so from low to high, okay, you'll need a carrier, and at the same time, class, you'll be using energy. Now, One of the things class that we have to remember about carrier-mediated transport mechanism is that it has specificity. Ibig sabihin, class, specific compounds lang ang pwedeng pumasok sa carrier. Okay? Pwedeng magkaroon ng competitive inhibitions. What do I mean when I say competitive inhibition? Alright? Say, for example, class, here's a carrier. Okay, may laman na siya. May laman na siyang solute. Pero here comes now, class, another solute. Kunwari, star na lang. Which has a higher affinity for the carrier. Okay? Kumbaga, class, sabihin natin si carrier ay isang babae. Nililigawan ng isang solute, yung bilog. Okay? Ngayon, dumating yung mas pogi na manliligaw ni carrier. Itong star. Sa tingin mo, class, sino ang i-entertain ni carrier? Yung bilog na blue or yung star? Mas pogi ito. Mas mayaman. Mas mabait. Mas matangkad. Okay, sa tingin nyo, sino ang i-entertain ni carrier?
It was pogi,
Okay,
sir.
very good. Right, so I hope I guess yun naman kasi, mas mataas kasi ang affinity niya towards the carrier as compared to the blue molecule. So nagkakaroon class ng competitive inhibitions. Ibig sabihin, class, nakikipag-compete yung solute na to, which has a higher affinity towards the carrier. So sila ngayon ang papalit dito sa nauna. Okay, so nadi-displace ngayon, class, yung mga molecules na to. At papalitan sila ng molecule na mas mataas ang affinity sa carrier. Okay? So that's what we call, class, competitive inhibitions. Alright? Yung star. Very good. Okay, makes sense naman, class, right? Okay, in terms of compatibility. Right? Sometimes it's not bad to let go if you know that you deserve something better. Right? Anyway, but then again, huwag na nga tayo. Ibang usapan na pala yun. Usapang buhay na yun, hindi na yan usapang kinetics. Alright? Anyway, again, since we're using here a carrier molecule, so isa sa mga limitations to class is that it undergoes saturation. Okay, it can saturate. So hence, class, it's best described using the Michaelis-Menten equation. Okay? Pero again, class, I'm not gonna teach you guys the Michaelis-Menten equation. Usually, ginagamit din to, class, for enzymes because remember, enzymes can be saturated as well. Limited lang yung amount of solute na kaya niyang i-metabolize. Okay, so I won't discuss, class, the Michaelis-Menten equation here. Right? Pero, class, I'll be focusing more on the order of reaction, which is the zero order. Zero order kinetics. Okay? And because it uses a carrier class, it can still be poison. Okay, a carrier can be poison. So here's example, class, ng ion pair transport na in-explain natin kanina. So di ba sabi ko sa inyo, ang membrane natin, class, normally negative, ang charge. So an organic anion, class, cannot easily enter the membrane because it's negative, negatively charged then. Now, however, if that organic anion pairs up with an organic cation, such as mucin, okay, it creates, class, a neutral complex. And this neutral complex can just easily enter the cell membrane. At once na nakapasok na sila sa cell, maghiwalay na lang sila to initiate their effects. Okay, especially if the organic anion. It can go to its target site. As for mucin, class, it's just a normal, substance that goes in and out of the cell. Okay. Now, what about vesicular transport? So, by definition, class, it is the process of engulfing particles or dissolved materials by the cell. And there are two types. We have the endocytosis and exocytosis. Pag sinabi natin endocytosis, it involves two types, phagocytosis and pinocytosis. Pag phagocytosis, ito yung cell eating. Pinocytosis would mean cell drinking. And when we say exocytosis, class, it's the reverse of endocytosis. Okay? Kung endocytosis papasok ng cell, exocytosis palabas ng cell. So creating a vesicle and pushing out whatever is the content of the cell. So form intracellularly and fuse with the plasma membrane. So it can be constitutive or regulated. Constitutive meaning all the time may nilalabas tayo, may nilalabas yung cell natin na vesicle. Or regulated, class, wherein only after a specific stimulus occurs, okay, will an exocytotic process happen. Right? Pero again, since we're talking about absorption here, ang focus natin class will be more on endocytosis. Exocytosis class is involved more on the pharmacodynamic effects of medications. Like say, for example, certain drugs can trigger the release of norepinephrine from cells, okay, via exocytotic process. At the release of neurotransmitters, di ba? So, di ba, ang release of neurotransmitters class can either be constitutive or regulated. Yeah. Anyway. So, phagocytosis. So, as I told you a while ago, class, endocytosis ang pinaka-main topic natin here. Okay, which involves either phagocytosis or pinocytosis. Now, there is another type of endocytotic process class which is receptor-mediated, meaning drug molecule. It is a very specific absorption mechanism wherein involved ay isang receptor. Now, let's talk about class the absorbing surface area. So, skin is much less permeable than the mucosa. Okay? And as we've said a while ago, class, the larger the surface area is, okay, mas mataas din ang absorption. Let's say, for example, class, skin natin is only 1.73 meters squared on average. Now, this is the average surface area class for a 70 kilogram person. Okay? 1.73 meters squared. The GI tract, on the other hand, class, look at this. It's approximately 120 to 200 meters squared in surface area. Compare that class to the skin. Diba? So, between the skin and the GI tract class, mas malaki ang absorbing surface area ng GI tract natin. So, hence class, mas marami siyang na-absorb. A 120 to 200 meters square surface area class is as big as a tennis court. Actually, probably much bigger pa nga to eh. Okay? Now, you might be wondering, paano nangyari yun, sir? Paano nagkasya ang 200 meters squared sa loob ng bituka natin? Okay? To the point na mas malaki pa yun, sir, kaysa sa balat natin. Okay? You have to remember, class, that the small intestine, okay, our small intestine class contains what we call a villi. Okay? Villi. Yung villi na yan, class, ganito yan. Yung parang hair-like projections. Tapos yung mga villi na yan, may mga microvilli pa. Okay, which further improves, class, the surface area of our intestines. Okay? Now, class, imagine nyo na lang, class, i-stretch out mo yung villi na yan. Palaparin mo. Di ba lumalawak siya? Okay? The villi kasi, class, again, the purpose of the villi here is to increase the absorbing surface area of the gastrointestinal tract. Okay? Hence, class, if you stretch out now those villi, including the microvilli, okay, pwede siyang ma-stretch to 200 meters square, 120 to 200 meters square of a surface area. Right? Now, not only that, class, the small intestines also contains a good blood supply. We call this the mesenteric circulation. Okay? Yung mesenteric circulation natin dyan, class, it allows for the GI tract to have good blood supply. Hence, class, the transport of drugs from the GI tract to the various parts of the body is possible because of the mesenteric circulation found in the GI tract. Okay? So, the blood flow to the GI tract is important in carrying the absorbed drug, okay, to the systemic circulation. So, the capillary network and lymphatic vessels perfuse the duodenal region of the peritoneum. Okay, approximately 28% class of the entire cardiac output is distributed to the mesenteric circulation. Right? And it's usually increased after meals and decreased after physical work. It's increased after meals, class, because after digestion, kailangan nagtatawag ng dugo yung ating GI tract. Alright? Then the lymphatic circulation naman bypass the first pass effect because drug absorbed through the hepatic portal vein is avoided. It's important for the absorption of dietary lipids and lipophilic drugs. Okay, the lymphatic circulation, class, utilizes the lymph nodes. Okay? Excuse me. So as I've told you a while ago, class, what makes the small intestines having a high surface area is because of the presence of this villi. Okay? Kasi yung villi na yan, may mga microvilli pa, which again increases the surface area of the small intestines. Next one is gastrointestinal motility. So we've mentioned this last meeting, right? Gastric emptying versus peristalsis. Okay? So ang sabi nating class, ang pinagkaiba lang naman ng gastric emptying sa peristalsis is, pag gastric emptying is the movement of the drug or the food from the stomach going down the intestines. Okay, yun lang naman yun. Now, does absorption take place in the stomach? Sabi natin, generally, ano ba sabi natin tungkol dito? Okay? So, sabi nga dito, class, di ba, generally, walang absorption na nangyayari sa stomach natin. Kasi karamihan ng absorption nangyayari sa small intestines. So, therefore, gastric emptying simply affects the rate of absorption, but not the extent. Okay? Not the amount of drug, not the amount of absorption. Okay? On the other hand, peristalsis naman plays a vital role in absorption because that's already in the small intestines. So, the faster the peristaltic movement is, the lesser will be the absorption because ang nangyayari sa transit time natin is nababawasan or ang tinatawag nating residence time. Okay, transit time and residence time is just the same. On average, class, the small intestinal transit time is 3 to 4 hours. Okay? It's 3 to 4 hours, so meaning the drug stays approximately 3 to 4 hours within the intestines before it is completely absorbed. A drug or a food. Okay, and a drug must have a sufficient time at the absorption site for optimum absorption. Okay, so let's talk about gastric emptying, class. So assuming, sabihin natin, class, yung kitchen sink na to is the stomach. Okay, so here's the stomach. And the piping here is the intestines. Okay, where absorption takes place. Okay? So let's have here, class, a comparison. Which food will be absorbed faster? Okay, will it be the burger or the vegetable sandwich? So assuming, class, yung gastric emptying time ng ating burger is approximately 4 hours. Okay, it took 4 hours para bumaba ang burger from the stomach down the intestines. Then, class, si vegetable sandwich naman, approximately 1 hour bago siya bumaba sa small intestine. Now, question, class, sino ang mas mabilis ma-absorb? Is it food A or food B? Okay? Sino ang mas mabilis ma-absorb?
Food B po.
It's food. Sorry, Miss Havines, ikaw ba yun?
Food B po, sir.
Okay. Why did you say food B?
Kasi, sir, ano po, 1 hour lang po siya.
Okay.
Kesa po dun sa food A na 4 hours po bago bumaba.
Alright, very good. Okay, di ba sabi natin, class, buti natin ha, okay, walang nangyayaring absorption sa stomach. Okay, technically speaking, most of the absorption, class, will take place in the intestines. So therefore, class, ang goal natin ay bumaba yung pagkain, bumaba yung gamot from the stomach down to the intestines in the smallest amount of time. Alright? So correct, class, food B will be absorbed faster than food A. Okay? Because, class, ang sabi nga natin, pag mas mabilis bumaba, okay, an increase in gastric emptying rate would mean an increase in your absorption rate. Okay? Hence, class, mas mabilis ma-absorb yung gamot. An increase in gastric emptying time, please remember, time and rate, class, are inversely proportional. So if there's an increase in gastric emptying time, there will be a decrease in your absorption rate. That's what happened here, class, kay food A. Okay, si food A kasi, ang tagal ng gastric emptying time niya. So therefore, class, it's going to be absorbed much slower as compared to food B. Right? The vegetable sandwich. Okay, please remember lang, class, that what is affected in gastric emptying is simply the rate of absorption, not the amount of absorption. Are we clear with that? Okay. It does not affect the amount, only the rate of absorption. So are we clear? All right. So what are the factors, class, that can increase gastric emptying time? Okay, or meaning causes a delay in absorption. If your food class is high in protein or fat, it makes the food viscous. Okay? Siyempre, pag viscous class yung food natin, okay, mabagal yan bababa. Dahil nga masyado siyang malapot. So, hindi siya makakababa agad-agad sa small intestines. Presence of gastric ulcers can also impair or delay absorption kasi hindi makagalaw ng maayos yung ating stomach. Okay, drugs that impair GI motility, stress, heavy exercise, or lying on the left side. Now, okay, lying on the left side daw can delay absorption. Because class, when you lie on the left side, okay, pangit na yung drawing ko. Pero kasi when you lie on the left side of your body, most of your food stays in this portion. Okay? Pag nandito kasi class yung gamot natin, ang tendency is hindi siya na-digest ng maayos. Wala siya dito sa yung sa greater curvature ng ating stomach. Okay? If you lie on your left side kasi raw class, andito lang yung food and hindi na-digest ng maayos yung food, so hindi siya nakakababa agad-agad sa small intestines. Kasi again, isa sa mga requirements ng ating intestines, okay, is that dapat ma-digest ng maayos muna yung food bago siya bumaba ng intestines. Okay, that's why class, oftentimes, if you, after eating, at gusto nyong mahiga talaga, okay, it's always recommended class to lie on your right side because if you lie on your right side, nandito yung food. Okay? And therefore, class, mas mabilis siya na-digest. Okay, yun ang nila, yun ang explanation dito. Right? Stress, of course, class, that's the reason why when you're stressed, well, for some people, hindi agad-agad sila nagugutom. Okay? Kasi bumabagal yung kanilang gastric emptying. Okay? Anyway, what are the factors that increases gastric emptying naman? Normally, hot food. Okay? Pwede rin naman all cold drinks. So, all variation in temperature of food can decrease gastric emptying time. Mild exercise lying on your right side, yun ang sabi natin. Okay, gastrectomy, diabetes, drugs that increases GI motility, like metoclopramide, spicy food. Okay, kaya nga papansin nyo kasi, di ba, parang ang sarap-sarap kumain pag spicy yung food. Okay, parang napaparami yung kain mo. Right? Because, well, one thing, class, it increases gastric emptying. So, mabilis bumaba sa intestines yung food. So, therefore, class, feeling natin, marami pa tayong kayang kainin. Okay? Kasi may space pa sa ating stomach because naibaba agad siya papunta sa small intestines. Okay? Yun, kung mahilig kayo mag-Korean, mag-samgyup, tapos kimchi-kimchi, ganyan. Yung spicy food class, kaya napaparami yung kain natin. And of course, a hot meal. Now, what about peristalsis? So, sabi natin, it refers to your intestinal movement. So, the question now here, class, if we're dealing with peristalsis is, we're talking about the amount of drug being absorbed. Pag gastric emptying kasi is the rate of absorption, while peristalsis talks about the amount of drug absorbed. So, let's have this an example, class. So, which food will be absorbed more? Let's say burger class, food A, wherein yung kanyang residence time, meaning the amount of time it stayed in the small intestine is 4 hours, versus food B, okay, wherein ang kanyang residence time class is approximately 1 hour. So, sino sa tingin nyo sa dalawa, okay, ang mas ma-absorb? Mahapdisat yan ng manghang. Well, that's true also. It causes irritation kasi. Yes, Mr. Nesho?
A po, sir.
Okay, why? Yan. Alright, so very good. It's okay, it's okay. So, Mr. Nesho, can you explain why did you say food A?
Because meron po tayong site po kasi absorption yung intestine po natin, di ba po? And then, due to sa mga villi, and since mabagal yung movement ni food A, mas na-absorb siya kaysa doon sa food B na diretso siyang excrete sa clearance.
Okay, very good. So that's correct. So definitely class, food A will be absorbed more as compared to food B because it stayed longer in the intestines. Mas na-absorb siya. Right? So an increase in peristalsis class, remember, decreases absorption because it gives your food less time for absorption. So an increase in residence time increases the absorption, meaning more contact time with the intestines. So now class, let's talk about the effects of food on GI absorption. So presence of food class in the GI tract can usually affect the bioavailability of drugs given perorally. Normally, class, in the presence of food, it can cause a delay in gastric emptying. So meaning it increases gastric emptying time. Other than that, it also stimulates bile flow, okay, which causes complex formation with our drug. Okay, it causes a change in pH. Remember, class, how pH plays a vital role in how the drug will be absorbed. Okay, and it also increases the splenic blood flow, change in luminal metabolism of the drug substance, physical or chemical interaction of meal with the drug product or drug substances. Now, normally, it is best to give a drug without food. Normally. However, you have to consider, kasi if you want to increase the absorption, kasi nga, class, normally food delays gastric emptying. So, napapabagal yung absorption ng ating gamot. Okay? Now, ang problem kasi, class, madalas sa mga gamot natin is that it can cause GI irritation. And what is one way to relieve us of that GI irritation? So, normally, class, to relieve that GI irritation, ang ginagawa natin is we administer the drug together with food. Okay? So, di bali nang ma-delay ang absorption niya, class, kasi ma-absorb pa rin naman yan eh, kesa naman sumakit pa ang tiyan mo. Kaya oftentimes, class, ang recommendation natin would be to take the medicine with meals, just to avoid GI irritations. Okay? However, class, there are specific drugs with specific contraindications talaga, which cannot be administered together with food. Let's say, for example, tetracycline. Tetracycline, class, it creates a complex with calcium that is found in dairy products. Hence, class, it's a big no-no to combine tetracycline with milk or any compound that contains calcium. Okay? On the other hand, some food or some medication, class, needs the presence of specific types of food to increase their bioavailability, like griseofulvin. Griseofulvin, class, is an antifungal drug, and its absorption is increased with high fat content. Okay, with high fatty meals. All right? So what else? There are some drugs na hindi pwedeng ma-combine with bile. So because bile, class, acts as a surfactant involved in the digestion and solubilization of fats through micelle formation. Okay? And food, just so you know, class, can also stimulate the production of hydrochloric acid. Kaya nga tingnan nyo, class, how do you administer PPIs, proton pump inhibitors, like omeprazole, lansoprazole? Is it before meals or after meals? Na-discuss nyo na ba sa psychology, or have you experienced using PPIs? Proton pump inhibitors? Omeprazole, na-try nyo na bang gumamit? Sa mga may GERD, okay, or hyperacidity. Alright.
Before meal, sir?
Okay. It's actually, class, so for the information of everyone, omeprazole, class, is given, ano ba munang ginagawa ng omeprazole? Or a PPI. Okay? PPIs, class, in general na lang to, alright, para lang mas maintindihan natin, decreases acid production. Okay? It decreases acid production. Now, if you eat, class, when you eat, what do you think happens to acid production? Tataas. Very good, Mr. Reyes. Okay, tataas ang acid production. Now, if you take omeprazole, class, after meal, it defeats its purpose. Kasi anong purpose niya? It stops acid production. Eh kung tinake mo siya after meal, andyan na yung acid. Wala na magagawa si omeprazole. Hindi kasi neutralizing agent si omeprazole. It doesn't neutralize acid. It stops the production. Ano pa ang purpose niya kung may acid na yung tiyan mo? Kaya normally, class, omeprazole, or any PPI for that matter, is taken before meals. Before any acid is produced in the stomach. Okay, does that make sense, class? Kaya normally PPIs are taken before meals. Normally 30 minutes before meals. Okay? So next time, class, pag kayo ay nag-dispense ng PPI, always inform your patient to take this before meals. Well, when you say before meals, class, that's 10 to 30 minutes naman. Alright? Okay, what about drugs that affects absorption? Anticholinergic drugs like loperamide reduces stomach acid secretion. Or We call this, okay. Basta may mga most of our anticholinergic drugs class tend to reduce stomach acid secretions. Tricyclic antidepressants, because of their anticholinergic property, they can also reduce peristalsis. Metoclopramide stimulates stomach contraction, relaxes the pyloric sphincter, and increases intestinal peristalsis in the GI tract. So hence class metoclopramide, since it stimulates stomach contraction, tends to increase gastric emptying. Okay, napapabilis yung pag-empty ng ating stomach. Antacids creates a non-absorbable complex, and cholestyramine creates a non-absorbable ion exchange resin. Cholestyramine, just so you know, class, is used to control, it decreases cholesterol inside the body. So in terms of body position, sabi nga nila, lying on the left side reduces the rate of gastric emptying. Hence, it's advisable, class, to lie on your right side after eating. Pero of course, wag ka munang mahiga after eating because, class, that could cause GERD. Okay? So less viscous solutions increases gastric emptying. Kaya normally food tends to decrease gastric emptying because it makes the contents of the stomach more viscous. Okay, emotional states, stressful emotional states normally causes stomach contractions and gastric emptying rate to increase. In depression naman, stomach contractions and gastric emptying rate decreases. So when you're depressed, tendency hindi ka kumakain masyado. Okay, pero for some people who are stressed, mas mabilis ang kanilang gastric emptying rate, hence napapakain sila ng mas marami. Bile salts reduces the rate of gastric emptying. Okay? And disease states, like in diabetics and in patients with local pyloric lesions and hypothyroidism, the rate of emptying is usually reduced. Especially hypothyroidism, class, which decreases metabolism. Okay, it's a condition wherein mababa ang metabolism mo. And hyperthyroidism naman, gastric emptying rate is increase. Kasi mataas naman yung metabolism. Okay, in gastric surgery, gastric emptying difficulties can be a serious problem after surgery. Okay? All right. So that's pretty much it, class, for the